Right, so today we want to finish our data structure part. Our last data structure is graphs. Okay, so let's first finish that one. So then we have just one more topic, then that syllabus is also over. Okay, right. So our last data structure is the most general data structure, uh, graphs, and that is the most widely used data structure in real world applications as well. At the same time, the most or the hardest data structure to model program. Okay, so therefore we will be doing less coding and more theory for the graphs, not because we can't code it, simply because it takes more and more time. Okay, and the examiners are also not that interested in coding solutions for graph data structure simply because it's too complex to for you to remember and write in the exam papers. Okay, right. So let me open the note. So this is our last data structure. And of course, this is the most general data structure. So graph is collection of nodes freely connected, no restrictions. So therefore, this is the most general data structure, right? It's non-linear and also no restrictions on how to connect, okay? Or number of nodes, number of connections, nothing. Again, the terminology, some of the terminology share from trees, right? For example, so this is called vertex or node. In trees, we call it node, but in graphs, mostly we use the word vertex or node is also fine. And this is called edge or arc. So these are all edges or arcs. These are nodes or vertices. Okay. So then few more concepts. Adjacency. So the two nodes are said to be adjacent if there's a single vertex or single arc. Okay. If those two nodes are connected by single vertex, sorry, single edge or single arc, so those are adjacent nodes. For example, G and F are adjacent, but A and C are not adjacent. Okay. Right. Adjacency. So then path. Path means when you start from one node, if you can reach another node by going through these edges, so that is a path. For example, HGIJ is a path. But HGA is not a path because you can't directly go from G to A. But HGFA is a path. Okay, so that is called path. These are very simple things, therefore I'm doing it fast. So then degree of a vertex. So remember these are the vertices. So the degree of a vertex is number of edges from that vertex. For example, here there are two edges. So therefore the degree of this vertex is 2. Okay. And so on. So here the degree of V2 is 3. Degree of V3 is just 1. Okay. Here the degree is 0 because it's not connected to any of the other nodes. That is degree of a vertex. And I forgot to mention that sometimes these edges can be directed or non-directed. For example, say we have something like this. So if it is something like this, it is not directed. That means it's both ways, A to B and B to A. You can go from A to B, you can go from B to A also. So these are not directed graphs. But sometimes what you have is directed graph. So then A to B is one concept, B to A is another concept. Sometimes it's only B to C, but no C to B. Sometimes you have A to B as well as B to A. So that is a directed graph versus non-directed graph. So then what is a loop? So loop means you can start from one node then come back to the same node in a path. If it is directed, you must have directed arrows. If it is non-directed, of course, you can always consider it as both way. If it is a non-directed graph, always there's at least one loop because you can go there and come back because non-directed means two direction. But in directed graphs, there can be situations where none of the uh, no loops are there because you can go from here to here, but you can't come back to the same place by any means. But sometimes that is possible, right? Then order and size of a graph. Order of a graph is number of vertices. We denoted by V absolute value. Size of a graph is number of edges. Number of vertices is order. Number of edges is size. Sometimes number of edges can be different from number of uh, vertices. Okay. So just remember this because in big O notation you may see this, right? Number of vertices, number of edges. Right. Bit of categorization of graphs. Uh, so as I already mentioned, there can be directed graph and undirected graph or non-directed graph. So undirected means basically two-way, right? Non-direction means actually bidirection. Another way, name for bidirection is undirection. Direction doesn't matter. Means if you go from A to B, you can come from B to A, or the direction doesn't matter. Maybe that is just a connection. But these are directed graphs. Okay. So the next concept is connected graph. The graph is said to be connected if there's at least one path from every vertex to every other. Right? From every vertex, you can go to every other vertex. So then this graph is connected. For example, if I start from here, I should be able to go there, I should be able to go there, I should be able to go there. If there's another thing, maybe yes, I can go to there also. If I start from here, I can go to any of these places. Right? From any nodes, you can go to any other nodes. But if that is not the case, that is not a connected graph. So you can see from here I can go there, but from here I can't go there. But this is just one graph. So this is not a connected graph. So then we have the concept of simple graph. Okay. So a graph is said to be simple if no self loops or multi-edges. Self loop means from your node, you can come to your node. There's a path from X to X. Okay. Not X to Y. So that is called self loop. Multi-edge means there are multiple ways you can go from A to B. You can go like this or you can go like this. Maybe you go by train or you go by bus. So then you have multi-edge. If there are no multi-edges and no self-loops, that is called a simple graph. Okay. And it must be undirected. Sorry, undirected. So then what is mean by multigraph? So multigraph means it can have multiple edges like this, multiple edges. And of course, it can have self-loops as well. So then it's a multigraph, or sometimes you call it pseudograph. Pseudograph. So then we can have weighted graphs. So that means when you go from one node to the other, there can be a weight associated with that. Say ABC, maybe this weight is 8. So far we did not added any weight here. But now we have, maybe this is the distance from A to B, B to C, or the cost, or anything else. Most of the time, your graphs will be weighted graphs. Okay, weighted graph. It can be time, cost, and so on. Okay. Right. So the next classification is directed cyclic graph versus directed acyclic graph. Okay. So as the name suggests, it must be directed. Direction is there. If cycles are there, it's cyclic graph. If cycles are not there, it is a cyclic graph. Okay. For example, here you can clearly see there's a cycle. No, no cycle. Because if you start from this, you can go to there, but you can't come back. If you start from here, you can't go anywhere. If you start from here, you can only go there. So there are no cycles. So this is direction is there, but no cycles. So there is directed. Sorry, do we have cycles here? Go here to here. I think this one has a bit of issue, right? Go there, go there. I think this graph is wrong actually. Okay, so this example is wrong. You can see that there's no cycle here, right? You can go from T1 to T2, T2 to T3, but not come back to T1. Okay. So therefore, actually this should have been something like this. Okay. I will fix that. Okay. So now it is not, it's a directed cyclic graph. Okay. Directed cyclic graph. But here, let's see, we have cycles. You can go from here to here, but that's all. You can go from here to here, that's all. You can go from here to here and here to here, that's all. No cycles. No cycles. Right? You can start from here and go there, that's it. Start from here, go there, that's it. No cycles. Right? Let's assume this one has this arrow, okay? So this is cyclic graph, but this is a cyclic graph. So then we have complete graph. Complete graph means each of vertices has an edge connecting to all others, direct edge. So that means from any vertex, there's a single edge to reach the all other vertices. Just single edge. Okay. So those are something like this very special graph. This is a complete graph. This is a complete graph. Okay. This is another complete graph. Okay. Because from any edge, you can go to, there should be another one. From this edge, you can go to this, and this. From here, you can go to any of these in a single edge, right? So there's one complete graph of size 3, one complete graph of size 4, one complete graph of size 5, one complete graph of size 6. Each size, you have only one complete graph. Okay. And of course, if you want, you can have additional connections. If it is multi-graph, okay, multiple paths are available, but there must be single edge. So the next one is regular graph. Regular graph is a graph with every node having the same degree. Every node, now this is different. Now here the degree of this node is 2. Degree of this node is also 2. You can say every node has degree 2. If you take this one, every node has degree 3. Right? Degree 3. Those are also some special graphs. So we don't care what is that degree, but it must be the same for every node. Right? So here every node has degree 1, 2, 3, 4. Right? Here every node has degree 2. So this total thing is also regular. Because every node has degree 2, though it's disconnected. Okay. So you can have this kind of odd shapes also. Every node has degree 3. Right? Every node has degree 3. So these are called regular graphs. So then the finite graph versus infinite graph. The finite graph means you have finite number of nodes. It's 5, it's 10. But if you have infinite number of nodes, there's no end. It's an infinite graph. Of course, we are more interested in finite graphs. Okay. Now you can think of what are the possible usages of graph. For example, entire Google map is, especially when you travel, it's a graph. Facebook, your friends' friends, it's a graph. Right? All the social media, not only Google, Facebook, Instagram, it's a graph. Your timeline is also graph, right? It's sort of a linear list initially. But when you watch a video, now you are getting some videos. And you get back to your original graph, right? So not only that, schedules, task in a project, distribution of oil, distribution of electricity, electrical grid, it's a graph. Your transmission of data in a computer network graph. So this is where you have the most number of usages. Okay. Family, society, your relations, right? Your friends. It's a graph. It's a graph. So this graph analysis is very important in propaganda, marketing. So there are some people called social influencers. So you need to strategically identify social influencers so that you can influence the entire society. Because otherwise, part of the society you don't address. Okay. So think about the practical things, right? Because this is very practical subject. Right. Some more properties of graph. Okay. So number of edges must be if you have number of vertices n. Okay. If it is directed, number of edges must be less than or equal to n into n minus 1. Okay. If it is directed, if it is undirected, it must be n into n minus 1 divided by 2. So this says less than, okay, not the upper bound. There's no upper bound actually. Okay. But least you must have this number of things. Right. So the next thing is path. Path means you start from one place, ended up in another place, like you just travel. You go from here to here, here to here, here to here. It's a path. Okay, path. If the path is said to be simple path, if you don't visit the same vertex twice. Right? So that means you don't visit the same vertex twice. So then it's a simple path. But there can be path where you visit the same vertex twice. Okay. So then it's not a simple path. Right. So likewise, there are terminology, right? So you don't need to worry too much about beyond that. Okay. So just you need to understand what is a path is and what is simple graph, connected graph, directed versus undirected graph, and so on. Right. So this is another concept, strongly connected graph. Right. Strongly connected graph. connected, weakly connected, strongly connected. If there's a path from any vertex to any other vertex, we call it connected graph. So this is because from any vertex, you can go to any other vertex. Not directly, right? Maybe indirectly. Because this is bidirectional. But if it is a directed graph, and you can go from any vertex to any other vertex, it is called strongly connected. This is when it is not undirected, just connected. Even when it is directed, still if you can go from any node to the any other node, is strongly connected. For example, if I start from C, I can come to B, C to D, D to B. I can go from C to A, C to D, D to B, B to A. If I start from B, I can go to D. I can go to F, I can go to A. If I start from A, I can go to any of these. If it is directed, and from any node, if you can go to any other node, it is strongly connected. If it is undirected, then from any node, if you can go to any other node, it is connected. So then what is meant by weakly connected? Weakly connected means it's a directed graph. If you consider the direction, no, you can't go from any node to any other node. But if you forget about the direction, it become connected. So then it's a weakly connected. So weakly connected means it's directed graph. It's not strongly connected. But if you ignore the direction, it's connected. So then we call it weakly connected. Okay. So that is only if you ignore the direction, it is connected. Strongly connected means it's directed and with considering your direction, still it's connected. So connected is it's undirectional and from any node you can go to any other node. Okay. So next one is connected components. Connected components means your big graph is not connected. That means from any node you can't go to any other node. You can clearly see that from this node you can't go to this node. From this node you can't go to this node or this node. But if you consider these subcomponents, this subcomponent is connected. This subcomponent is connected. And this subcomponent is connected. So therefore, these are not, this is just components, but those components are connected. But as a whole, the graph is not connected. So then we call these connected components. Connected components. Okay. So this graph is not connected, but this graph has three connected components. Right, our final theory concept is articulation vertex or cut vertex or cut point or separation vertex. Same concept, different words. So what is mean by cut point or cut vertex or articulation vertex? So it's a point or vertex. If you remove that, now it is connected. If you remove that, it become non-connected. So there are such points. For example, if I remove this one, right? If I remove this one, it is not going to make it different, right? Still it is connected. From any node, you can go to any other nodes. But what happens if I remove this one? Now you can see that these two are separated. So therefore, this is a cut point. This is not a cut point, but this is a cut point. So cut point or articulation point is a point. If you remove that, it becomes connected components. Your connected graph becomes connected components. It's not no longer connected graph. Such points are called cut points. So these are very important in wars, because the moment you attack this kind of a point, the forces the army or whatever, they get separated. They get separated. So these are the very strategic points in wars. Okay. And supply chains and so on. Because all of a sudden these two are isolated. But not something like this. So it's not going to make it disconnected, right? Still, any node can be reached from any other node. Yes, they are lesser supply routes, but still they are not isolated. But this is you completely isolated. So this is a cut point. Actually, this is the only cut point. No, not only this one. This is also cut point because then these are lost. This connection is lost. Or if this node D is not there, okay. So now separated. Actually, this guy gets separated alone. Or maybe you cut this. So still it is separation. You can either get rid of a node or get rid of edge. This get rid of edge itself is make it disconnected. But articulation point means you remove the point, not the edge point. So that actually this make it isolated into three subcomponents. This one alone, and this one. Okay. So if you have a graph and it has no articulation point, no cut points, it is called bi-connected graph. So that means by just removing any of the nodes, uh, it doesn't separate your graph into connected components. So none of those points are there. That means it's very stable. Especially in networking and so on, it's very critical that it's a bi-connected graph because that means single failure of a single node will never separate your communication into isolated subcomponents. Always there are redundancies. So in distributed computing and so on, not only that, even in war and so on, we always try to make it big bi-connected graph. Okay. We discuss about strongly connected components. Okay. Right. So now we move on to the modeling of graph because graph is the most general data structure. Right. Hardly any restriction. It's very difficult to model it. Unless you model it, you can't do any processing using programs. Because remember, stack is very strict data structure. You just add something on top of that. You can implement it using arrays. You can implement it using linked list. Queue is also the same, very strict data structure. You add it to the head, sorry, add it to the tail, take it from head. Again, you can use array or you can use linked list. So then we discuss about tree. Of course, implementing tree is more challenging than linked list, but still we manage, right? Because every node has two children. If it is binary tree, okay, binary tree. So every node need to keep track of its left and right. If it is non-binary tree, still it's possible, right? But only thing is we don't know how many children we are going to have, but still there's a control, there's a starting point. Always there's a root as long as it's a tree. From there you can have a logic to traverse and so on. Add nodes because you're adding nodes to these kind of leaves or non-leaf also you can add. They are the only concern was how many nodes can we add. If you have upper bound, then of course we can model it. But in graphs, any node can be connected to any other node. So therefore, there's no root also. There's no root there as a starting point. So therefore, this is very complex to model using conventional thinking. Because conventional thinking, we have a sort of a starting point, but there's no center or starting point for a graph. Every node has the equal level. So therefore, you need to have a different approach, different strategy when it comes to modeling graphs. Okay, modeling graphs. So the most popular approach is you model your vertices separately or nodes separately. You can keep it in an array or list, right? Say these are your nodes. You can just keep track that those are nodes. That's it. There's a node called A. There's a node called B. There's a node called C, D, E. You can just keep those nodes in a separate array. Maybe if the node label is ABC, char array. If those are strings like Gampa, Kurunagel, and so on, string array. Or some number, reference number, ID. So then you know what are the nodes available. If you want to remove a node, you remove it from the node array. If you want to add a node, you add it to the node array. But adding to the node array doesn't mean you have created these edges. Okay. So therefore, we need a separate mechanism to keep track of what are the current edges. Okay, current edges. So we keep track of nodes in a one-dimensional array. We need to keep track of edges. Edges, of course, you need to know from which to which. B to C, D to C, A to D. That is also not very difficult, right? So you must have a sort of array where you know that if there's a to D, that means there's link like this. Okay, right. So this is how you model it. First, we are going to create a class, vertex or node. So every node has a label, which can be char or integer like index number or whatever or string. Let's take it as char because we use A, B, C, D usually. And we have created a constructor so that you give me the label and we create the vertex object. Vertex object or vertex is another name for node. But here we have not kept any data. If you want, you can keep data also here. A node, some data, some more details about it. But we have not done that. Okay. And later we are going to introduce another Boolean variable to this vertex or the node class that is purely for our processing purposes during traversing. So it has nothing to do with the modeling of this, but it is mainly we are going to use it for processing. Okay. So therefore, let's not concentrate on that for the time being. Okay. So simply you have a label and maybe possibly constructor so that someone can just create a vertex with the label and we create the vertex object. Is it clear? Just like our linked list, right? Just like our tree node, linked list node. Right. So the next thing is modeling edges. So there are different approaches, different techniques to model these edges because we need to, your system must know that these edges are there. These edges are there. Right? How do you model these edges? So there are different techniques used by software developers, mathematicians who try to model this. So we will look at three approaches: adjacency matrix, adjacency list, and incident matrix. Right. What is mean by adjacency matrix? These are very simple concepts, okay? You can understand it in the very first impression, okay? It's not rocket science. So adjacency matrix is a matrix. You have done matrix in semester, sorry, in your O-level. Matrix, you can keep your data in a two-dimensional manner, like programming arrays. It can be anything that you are interested, right? Matrix. So if you have four vertices, it's 4 by 4 matrix. If you have five vertices, it's 5 by 5 matrix. It's a square matrix. Square matrix. You know what is a square matrix is, right? You have done it in O-level maths. It must be a square matrix, and it's either values are zeros or ones. Zeros or ones. For example, here we have A to C H. So that means A to C, it is 1. We have A to B. A to B, it is 1. We have A to D. A to D, it is 1. There is no A to A. So therefore it is 0. Now we can start from B. From B, we have B to A, B to D. B to A, B to D. There's no B to C, so therefore 0. There's no B to B, therefore it's 0. So then do the same for C. There's only C to A. Others are 0. From B, there's D to A and D to B. And the result is adjacency matrix. Super simple concept. Super simple concept. Okay. And it's always a symmetric matrix. Symmetric matrix means this is your diagonal. You can see it's symmetric. Symmetric. So why is it symmetric? Because if there's A to C, there's C to A. This is C to A, and this is A to C. This is B to A, and this is A to B. You can see. This is D to A, and there must be A to D. Yes. It's always symmetric. If it is bidirectional, definitely it's symmetric. But if it is unidirectional, it may not be symmetric because there can be A to C, but no C to A. And there's A to C, but may not be C to A. Maybe this is 0. So you need to understand this, okay? So therefore, if it is bidirectional, your adjacency matrix is always symmetric. But if it is unidirectional, it may or may not be symmetric. If it is bidirectional and you have this kind of a connections, still it is symmetric. But if there's at least one missing, then it's not symmetric. Right, so that is called adjacency matrix. If you have 10 vertices, you have 10 by 10 square matrix. Right. Second approach the mathematicians, software developers used is adjacency list. Adjacency list. So if you keep adjacency list, if you have 10 vertices, you have 10 elements or 10 list. So then say this is my starting point A. So from A you can go to C, you can go to B, you can go to D. You just keep those elements. From B you can go to A and D. From C you can go to A only. From D you can go to A and B. So you just keep those lists. Simple solution. So then we have adjacency list. Maybe this is array, though we call it list, right? It's not necessarily list like A to B, B to C. It can be a list like that. Or A, here you have B, comma, C, comma, D. Okay. Whatever the way. But in general, we call it adjacency list. List of adjacent element for each and every vertex. So these are the adjacent element for A. Adjacent element means you can go there in single edge. So this is a list of items. Okay. That is the second approach. Another possible approach is incidence matrix. Incidence matrix. This is not a square matrix. Remember, adjacency matrix is a square matrix. In incidence matrix, number of rows is same as number of vertices. If you have 10 vertices, you have 10 rows. Right? 10 rows. The number of columns is number of edges. Maybe you have 10 vertices but 5 edges. So then it's 10 by 5 matrix. You can see that if you take a column, it has only two one values. Just two one values. Nothing more than. Just two. And that represent H. So this represent A to CH. This represent A to FH. This represent A to DH. This represents C to FH. And this represents D to FH. And this is F to G. And the last one is B to E. So number of rows is number of vertices. Number of columns are number of edges. Of course, this is not a connected graph. So that is called incidence matrix. Is it clear the difference between the three? Adjacent matrix, which is always square matrix, and it is a symmetric matrix also if it is bidirectional. It has same number of vertices is the number of rows and columns. Incident matrix, number of rows is number of vertices, number of columns is number of edges. And each column you have only two one values. Here there's no such restriction, right? Each row can have multiple ones. Okay. Each column also can have multiple ones. But this is every column must have only two one values because it's every column represent an edge. Right. So those are three approaches. But in our we are going to do a bit of coding, not a lot of coding. We will be using adjacency matrix because that is the most widely used approach and the easiest in most cases. But there are some applications where maybe adjacency list is more convenient or even incident matrix is better. Okay, so now let's move on to coding part. So how do we model this? We model the vertices, so the nodes in one particular array, and then we need to model all the edges, arcs in another particular array. Okay. First, we need to create a vertex object. So let's first create the vertex object. Let's call it vertex. Vertex. And vertex has a label, say char. label. Okay. And we can create a constructor where you have a char parameter so that you can send the label. And this dot label equal label parameter. So you must be pretty familiar with these things, okay? I told you this is where you build your confidence about programming, okay? It's problem solving, right? So then we can create our our graph, okay, graph class and any other methods required, okay? Methods required. Right. In the graph, what we are going to do is we are going to create a list of, or we are going to keep a list of vertices, right? Vertex array, let's call it vertices. Right? And maybe in the constructor, because it's an array, of course, if you want, you can create a Java list as well, or our own list. But because we are going to create an array, because we try to use as much as possible basic things, remember in Java, when you create an array, you need size. Okay, size. Because without size, you can't create Java arrays. Maybe we can ask the user to tell what is the number of vertices. So the maximum we are planning to keep. Okay. Or else we can go for our own value. Okay, our own value. So here, of course, we have hard coded, but if you want, you can let your graph, because when someone create a graph object, let them do that. Okay, so let's create a constructor for graph. Okay, let's give a size here. In size. That is maximum number of vertices. Okay. Uh, Say num vertices. I just make it slightly different. So there we can create this array now. Right. Vertices equal new vertex of this number of vertices. Just to make it a little bit better. Okay. So then when someone create a graph object, you need to specify this is the maximum number of vertices we are going to give. Maximum, right? It's not exact value, maybe maximum. You can say max number of vertices. But then you can't give more than that. So then you need to keep track of the edges. So we are going to use adjacent matrix. Right? This to this. Right? This to this, that to that. So that you can make two-dimensional array, like A to B, A to C, C to D. Okay. One thing is you can have a char array. If you are having char, like A to Z as A to D as your vertices, your array is also going from A to D, A to D. That is two-dimensional array. But remember in arrays, you need to have integers numbers in Java. Your index number must be 0, 1, 2, 3. There's no associative sort of an array in Java. So therefore, we'll assume A is 0, B is 1, C is 2, and something like that. Okay, so that means it's a two-dimensional integer array. Int array. So let's call it uh, something like adjacency matrix. Sorry, not here. New. Okay, so we can create it in the constructor. Okay, so that is adjacency matrix equal new. Remember, it's a square matrix. New int max number of vertices is your number of rows and number of columns. That is a max, okay? It doesn't mean that it's always take that. Okay, so it's a in two-dimensional array, right? Two-dimensional int array. So that part is now done. Any questions on that? And by default, remember all your array elements are assigned zero, so therefore you don't need to do it, right? So this is optional thing actually in Java. When you create a int array, all your elements will be zero. Okay. So we are going to keep it one if there's a connection, right? So therefore this is optional part. Therefore I'll skip this because it's anyway zero. But it's always good to do like this so that specifically you make it zero. That is more for someone understand the code rather than right anything because this doesn't do anything because anyway values are zero. Okay, right. So now we need to provide add vertex and add edge methods, right? So that someone who create the graph can keep adding vertices and keep adding edges. Okay, say void add vertex. You need to give the label char label. That is add vertex. Then you need to give add edge or arc. So let's call it add edge. So one thing is you can use the char characters, right? A to B, B to D, but then we need to convert your A to 0, B to 1, and so on. So therefore, just to make our life easy, let's ask the user to convert and add it. Okay. So that means if it is A to B, you need to say 0 to 1, A to C, 0 to 2, B to D, 1 to 3, 2, 1 to 3, and so on. Okay. So therefore, int, say start, int, n. But we'll assume this is bidirectional. Okay. So therefore, even I can say x and y because I will assume this is for bidirectional, right? Not for unidirectional. From this edge to that edge. Right. So when you are given a label, what you are supposed to do, you are going to add it to the your this vertices array, because now the vertices array is already there. Okay, vertices array is already there. So though it look very difficult at the beginning, there's a way to solve problem. Okay, right. So now we need to keep track of how many vertices are currently in the vertex list. Because if you have five, the next one must be six one. Okay. Otherwise, you need to go through the array and find what how many values are there, which is time consuming. So the easier thing is you keep track of how many vertices are currently in my or how many nodes are in my node or vertex array. Okay. So num vertex. or current number of vertex because it changed. Vertex, which is initialized to zero anyway. Global variables are always initialized, integers are initialized to zero. And now we can add this, right, to vertices list. Okay. So first you need to create a vertex for this chart. So vertex v equal new vertex. You need to give the label. Examiners have not asked any coding so far from graph. Okay. So therefore, don't worry too much for the exam, but try to develop this by yourself. That will give you the confidence because I would say more than 70% of the students in final year, they don't have the guts, confidence to do develop their software final year project. Unfortunate, right? That means they have not done coding in semester 1, 2, 3, 4. Okay. So then do you think that we can fix it in final year? No, we can't fix it. මොකද පොඩි කාලේ කරන්න ඕන දේවල් ලොකු කාලේ කරන්න බෑනේ. Too late. ඕගොල්ලොත් ඔක තේරුම් ගනි ෆයිනල් එක ගිය දවස. වැඩ නොකරන කට්ටිය. ටෙක්නොලොජි ඉගෙන ගත්තේ නැති කට්ටිය. ඊට පස්සේ උඩ බලන් ඉන්නේ ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එක දිහා. සල්ලි අරගෙන එක එකාගේ පස්සේ යන්න වෙනවා. ප්‍රොජෙක්ට් එකක් කරලා දෙන්න බැරිද ප්‍රොජෙක්ට් එකක් කරලා ඉතින් මොන ලැජ්ජ නැති වැඩක්ද නේද ප්‍රොජෙක්ට් එකක් කරලා දෙන්න බෑ කියලා එනවා නම් තමන්ගේ ඩිග්‍රී අරගෙන ගිනි තියන්න බෑ. මොන මගුලක් අවුරුද්දයක් කරේ කියලා. Okay. And so you create your vertex object. Now you can add it to the vertices array. Okay. If you currently your number of vertex is okay, shall we make it -1 or maybe 0? Actually 0 means you are going to add it to the 0th location. So then number of vertex is 1. So 1 means your 0th location you have the last one. 2 means 0 and 1 is filled. Okay. 0 and 1 is filled. So therefore now we are going to set this to the vertices matrix. Vertices, its current location is this particular V. And then we need to increment this by 1. So therefore I can go for post or I can do it separately. Okay, මට ඕන මේක වෙනම කරන්නත් පුළුවන් වැඩි confuse වෙනවා කියලා හිතනවා නම් ඔයාලා. Because now we have one element. Next time you put it into the first thing and you take it to the second කියන්නේ ඊළඟ දාන්න ඕන second එක. one කියන්නේ දැන් එකක් තියෙනවා. ඊළඟ දාන්න ඕනේ කියන්නේ දැන් තියෙන position එකට. මොකද zero base නේ. Zero base. That is why you need to increment this afterwards. Okay. Right. So that we have done now. So that is this part is done. The method on postfix and the මෙහෙම දාලා තියෙන්නේ. නැත්නම් පස්සේ මම ඔක වෙනම කඩලා දානවා. Then add edge. It's very easy because you have this adjacent matrix created. You need to set it. It's a two-dimensional array. By default, all of values are 0. Now we are going to make it 1 from this index to this index. දැන් මම හිතනවා එයා A නම් 0 කියලා එවන්න ඕන, B නම් 1 කියලා එවන්න ඕන කියලා. නැත්නම් අපි ඔක මැප් කරන්න වෙනවා. හරි? අපි ඔක මැප් කරන්න වෙනවා. So we give that responsibility to the user. එහෙම නැත්නම් අපේ label වලට දාන්න කොහොම හරියට 0 1 2 3 කියලා. එතකොට කිසි ප්‍රශ්නයක් නැහැ. ඔයාගේ label එක 0, label එක 1, label එක 2 කියලා. හරි. Right, so that's it. That's it about creating your graph. Now we have the graph. Now the computer has the graph. Okay, so let's do a test class. Graph test. So let's create a graph. New graph. You must give the maximum number of nodes you are going to add. Let's say 10. That means you are not going to add more than 10. Okay. So then you need to keep adding your vertices. Right? Say A, like char, A, B, C, D, add करना बिल्कुल. But you can't have more than 10 now. If so, you need to increase this. If you want, you can just add 7. That is fine. But maximum is 10. Okay. So let's add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. අපි 10න් පාවිච්චි කරමු. If you try to add more than what you have specified here, you will get array index out of bound exception, runtime exception. Or else you need to validate that in add vertex method. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, now the user need to keep track that A is 0, B is 1, because අපි track කරන්න අපේ පැත්ත. එයාට චූටි responsibility එකක් ඉතුරු කරා. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if you develop this, if you write this code, you will get a lot of confidence, right? It's all about confidence, right? ඔයා ජීවිතේ ඉස්සරහට යන්නේ confidence එකට. සහතිකවත් වෙන දේවල් එක්ක නෙමෙයි. ඔයා යමක් ඉන්ටර්විව් එකට යන්නේ, ලෝක වෙන රටකට යන්නේ, ක්ලයන්ට් සයිට් එකකට යන්නේ. ඇයි? ඔයාට කවුරු යන්න පුළුවන්ද කියලා ඔයා කියනවා හා කියලා. හා කියන්නේ confidence. ඔයාට මේක වැඩ කරන්න පුළුවන්ද කියලා ඔයා කියනවා හා කියලා. ඒ කියන්නේ ඔයාට confidence නන්නේ. දැන් ඔයාටම තේරෙන්න ඕනේ දැන් මේ වැඩේ කරගන්න පුළුවන්ද බැරිද ඔයාට. ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එක දැන් කිව්වොත් පටන් ගන්න කියලා හෙට ඔයාට confidence තියනවද කරන්න. හරි. දැන් ඔයාට BIT degree හම්බුණා කියමු. So say assume that you got the BIT degree. Now you have a degree. Now you go through the top jobs, right? So listen to me very carefully, right? Now, now also they have jobs, right? Top jobs, when you go there, you can see they are asking for someone with a diploma, higher diploma, right? Trainees, internships. Then what එහෙමයි කියලා apply කරන්න පුළුවන්ද? What determine whether you are going to apply or not? Say now you have the diploma. දැන් diploma එක තමයි නැත්නම් තව සතියකින් කරේ. දැන් ඔයාලට එහෙම කරා කියලා මෙහෙම apply කරන්න හිතනවද? Right? So intern. So that determined by whether you have the confidence or not. It's your internal thing. It's your internal thing. I think intern. දැන් අපෙන් අහන intern දැන් එහෙම නැත්තම් අහන්නවද? මාව intern එකකට දාලා දෙන්න බැරිද? අන්තිමට හැම එකම දාලා දෙන්න තව කවුරු හරි අහවල් එකක් කවුරු හරි කියලා දාලා දෙන්න නෑ ඇතුළට. ඒ මෙලෝ confidence එකක් නැහැ නේ ජීවිතේ. නෑ. නෑ මේ තියෙන්නේ ආ දාලා දෙන්න ඕනේ CV එකක් දාන්න. ඔයාට qualification එක තියෙනවා. If you have the qualification. So these are internships, right? මේක කොහෙවත් ඩිග්‍රී එකක් අහලවත් නැහැ. නේ. ඩිග්‍රී එකක් අහලවත් නැහැ. කොහෙවත් ඩිග්‍රී එකක් අහලා නැහැ මේක. කොන්ෆිඩන්ස් තියෙන අයට ඇප්ලයි කරන්න කියලා දෙයි. මේක කරන්න පුළුවන් කියලා. right? So මේ ගේම ගහන්න තනිකර ඒකෙන් වෙන එකකින් නෙමෙයි. Let's see whether we have any other internships. this should be simple thing like internship. Sound podi podi වැඩක් තියෙනවා හරි. Suppose the day-to-day operations work with SQL, Excel, right? Diploma or degree. දැන් ඔයගොල්ලන්ට මේකට apply කරන්න පුළුවන් තව සතියකින්. Diploma or degree in IT, computer science, data science. So that is how you gather your experience, right? So then you build on top of that experience. ඔතන අවුරුද්දක් ඉඳලා ආයෙ ඊට පස්සේ apply කරන වෙන job එක. Expose into the software development, C Sharp, Python, similar, blah, 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 cloud platforms, right? Strong analytical and thinking and willingness to learn, ability to install, configure, blah, 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 troubleshoot software, right? You need to start somewhere, right? Start somewhere. හැබැයි ඉතින් මේක කළා intern digitalization. We are looking for proactive undergraduates. Undergraduates, okay? Or graduates. So make sure you get into that kind of mood, right? So that is why you need to do, right? I don't ask everyone to be software developers, but build these skills, okay? Right, so now we have added the vertices. Now we are going to add our edges. Okay, add our edges. So හිතේද මේක code කරන්න ඕනද? G dot add edge. First, let's build our graph. අපි ඉතින් graph එක හදාගන්න. Say this is my graph. It's a bidirectional graph. So that is why I'm taking a lot of time for the data structures subject, okay? Because this is practical subject. So this is my A, B, C, D, E, F, G. අපි මේක 6කට limit කරමු දැන් අපිට වැඩ වැඩි. වෙලා යනවා type කරා. Right? So let's say G up to G. So that means size is 7, right? Size is 7. Code එක වෙනස් කරන්න දෙන්නේ නැහැ, right? Now let's add the edges, right? So let's assume our edges are this. Say we have A to B. Say we have A to B, A to E, B to C, A to D. Okay. Say D to G, right? E to G, then D to F, okay, and maybe F to G. Okay, so those are our edges. A, B, C, D, E, F, G. Okay. Now let's add that. So now we need to keep track of that, right? Because we make it our implementation simple, right? So therefore this is A is 0, B is 1, C is 2, D, E, F, G. So therefore we have 0 to 1. 0 to 1. 0 to 1. So likewise, now I need to add all the edges. Zero to 1, 1 to 2. The order is not important. 1 to 2, 0 to 4, 0 to 3, then 3 to 6 and 4 to 6. And 4 to 6, 3 to 6, 4 to 6, then 3 to 5, 5 to 6, 5 to 6 or 6 to 5. Okay. Do I need to add it to the both ways, both sides? Okay, both sides. Is with intern opportunities available in this site? So you already saw that, right? So why you are again asking me when you already saw that there are internships? Right. So now we have model or done the coding and also we have write our test case, okay, for that. Okay. Right. Do you have any questions up to this point? Because we have done the add vertex method, add edge method. Okay, add edge method. Right. So I skip this one because anyway, initially it is all zeros. Right. Initially it is all zeros. Let me delete this. Right. So now we are done. Now we are going to look at some other operations. Now we have done this. Okay. Okay. Right. So now what are the other operations we are going to do? Because still we have not done any operation, right? We have just implement the add operation, adding vertex, adding an edge. Okay. Adding an edge. Right. So now we are going to look at few more concepts and then we'll revisit and the code. Okay. And we have used the adjacency matrix approach. And other thing is when there's a connection between A to C, we just mark A to C, not C to A separate. Remember, we have A to C and C to A. We just mark it as just A to C, not C to A. Okay. So therefore, what we have done is something like this. Actually, what we have done is sort of a directed one now. Okay. So let's take it back because we mark C to 0 to 1, 0 to 1. That is this one. 1 to 2, 0 to 4, 0 to 3, 3 to 6, 4 to 6, 3 to 5, and 5 to 6. So that is what we have done so far. Okay. That is what we have done so far. Okay. Right. So now let's look at few more theory concepts. Okay. Right. So our next concept is path matrix. Path matrix. So path matrix represents the possible paths. Right? Path matrix represents possible paths in our graph. Right? So you can go for level 1 path matrix. That means there's a direct connection. Basically, your level 1 path matrix is same as adjacency matrix because adjacency matrix shows the direct path between two nodes. So therefore, you can think of level 1 path matrix as same as adjacency matrix. But then you can think of level 2 path matrix level 3 path matrix, and so on. Say this is our graph. So what is our level 1 path matrix, which is same as adjacency matrix, that is B to C. Okay, B to C, that is this one. Then A to C, then C to E, okay, and then C to D, C to D. Then we need E to D and D to E, E to D and D to E, because this is directional. And now we have covered everything, right? So A to D, A to D. So this is either you can consider it as adjacency matrix or you can consider it as level 1 path matrix, because level 1 path matrix is same as adjacency matrix. Okay. So then what is mean by level 2 path matrix? Level 2 path matrix means can you go from one node to the other node by passing two edges? Then it must be one here. Okay. So let's erase this. For example, from A, I can reach BE in two steps through C. 1, 2. Right? What else? To D also I can reach like that. A to C and A to D. So therefore, that's all, right? Nothing else. Right, nothing else. So therefore, in path level 2 path matrix, there will be one from A to D and A to E. A to D and A to E, because that is where you can reach in two step from A. Similarly, in two step from B, where you reach? Two step from B. You can reach E, 1, 2. You can reach D, 1, 2, and that's all. Because you can't reach A at all. So therefore, it will be B to E and B to D. Right? B to D and B to E. So then what about starting from C? C. Two steps only, right? In two steps, I can reach D because you go from C to E and E to D. And in two steps, you can reach E also. C to D, D to E. So therefore, in C, we have D and E. From C, you have D and E. From D, in two steps, where can you go? In two steps, okay? You can go to E, but nowhere else to go. That means from D, you can't go anywhere in two steps. In single step, you can go to E, but in two steps, you can't go anywhere. So therefore, it will be all zeros for D row. From D, from D, you can come back to D. Why? You can go like this and come back to D. I forget about that. That means you can start from D, go there and come back to D in two steps. So therefore, D to D should be there. D to D should be there. So similarly, E also, you can go E to D and come back. Nowhere else you can go. So therefore, E to E is there. So that is your level 2 path matrix. Okay, level 2 path matrix. So then what about the level 3 path matrix? That means in three steps, where can you go? Say starting with B, go like this, and come here. From B, you can go to D. And also from B, you can go like this. So therefore, B, you can go to E or D. That's all, nothing else. Okay. E or D, nothing else. So similarly, you need to find, for example, if you take D, where can you go in two steps? Sorry, where can you go in three steps? D, maybe 1, 2. Again, if you repeat it, you can go to E because this is a loop, but nowhere else you can go. Okay, from D, right? Because you can, if you repeat, you can end up with D. Okay, that is how you prepare your path matrix. Of course, in this case, when you have loops, it creates infinite number of possibilities as well, because then you can go in 3 step, 4 step, 5 steps, and so on. Okay? So therefore, if you don't have these kind of self loops, after sometimes your path matrix will be all zero. All zero. That means there's no way more than that number of steps you can reach from one place to another. But when you have this kind of a loop or any other type of a loop, you can have any infinite possibilities as long as you allow traversing through the same edge twice. Right? So if you need all the possible paths, it must be sort of a union of level 1 path matrix, level 2 path matrix, level 3 path matrix, and so on. Okay, so that is called path matrix. Of course, if you want to keep in advance the possible paths, you can use it. Otherwise, of course, you need to process and get it dynamically, right? So that is what usually we do. We process and get it dynamically rather than you prepare your path matrix in advance, okay? But in the exams, they have asked about path matrix, right? You must know what is level 1 path matrix, which is same as adjacency matrix, the level 2 path matrix, level 3 path matrix, and so on. Okay, right. So now we move on to our next subtopic, that is traversing or searching graphs. Remember, we discussed about traversing in trees, right? Pre-order traversing, in-order traversing, post-order traversing. So similarly in graph also we can traverse. If you are traversing, you must visit all the nodes. When you visit all the nodes, you need to stop. But you need to traverse using a specific logic, right? Not random. Right. So let's discuss two type of traversing in graph. We call it depth first traversing, breadth first traversing. So depth first traversing means you try to go to the depth, or you try to go away and away and away from starting point until you have nowhere to go. Then only you see at that distance level, can I visit somewhere else? But you don't come to the beginning. You try to stay as far as possible away from the origin. When you are running out of options, only you are getting closer to the origin again. So that is called depth first. Right? For example, say this is my graph. Say this is my starting point. So now my task is do a depth first traversing. So I can go to B. Okay, so when you have a tie like this, usually we take the lower ascending order. B is the smallest guy, so therefore rather than visiting C, I can visit B. Likewise, you need to use the internal logic for that kind of a tie situations. Okay, so then my task is keep traversing. I try to go away from this. Say there's a bomb here, or if there's a tsunami, this is the beach. You try to go as much as possible, right, away and away. So therefore, from A you can go to B, then you can go to F, then you can go to H. But from H, there is no way to go. So then you have no other option, come back. Now we have already visited A, B, F, H. Nowhere else to go. In traversing, you don't traverse the same node twice. But in return trip, you can come back, but you can't traverse the same node twice. Now nowhere else to go, therefore you come back. You come back. Now you are in the original location. Now you can visit C. But from C, nowhere to go, therefore you need to come back. There you visit D, nowhere to go, you come back. You visit T, nowhere to go, you come back. And now nowhere else to go, you are exhausted. That means you have visited all the places, and therefore this is your final result. Is it clear? Okay, so that is called depth first traversing. Okay, depth first traversing. Right, do a depth first traversing for this. A, B, C, D, E, F. Anyway, even kids should be able to do this, okay? And when there's a tie, make sure you traverse the lower, right? If you can traverse to D and F, you must traverse D, okay? Assume your starting point is A.
So
And do
in
it.
request traversing, first we must go along the longest path.
No, I didn't get it. Can you repeat?
In request traversing, first we must go along the longest path.
Yeah, so that means if you can traverse further, you can traverse. If you are exhausted only, you come back. Okay.
Okay.
It's not longest, you try to go far away. Far away. Okay. Right. Do a depth first traversing for this starting with A. And everyone must get the same answer at the end. Right? You can't get different answers because this is a very systematic traversing. Assume this is bidirectional. That means you can go from any direction. But don't traverse the same point twice. You can come back to the same point in your return trip, but not traverse in the same point. Same node twice. Okay? Right. So let's traverse. I start from A. From A, I have two options, B or D, but B is the I traverse in ascending order, so therefore from A I will traverse B. Right? A to B. Okay. A to B. Then from B I can traverse C because that is the only option. From C I have three options. I will traverse in ascending order of nodes. So therefore I need to traverse to D. From D, I have two options, traverse A or F. Sorry, A or E, but A already traverse. So therefore you can't traverse the same node. So therefore you have to traverse now E, right? E, because you can't traverse the same node twice. From E, you have C and F, but C is already traversed. So therefore you need to traverse to F. Now from F, there's nowhere else to traverse because C already traversed. So therefore now you need to return and see whether there are any unvisited things. No, we have already visited this. So then come back. No unvisited things. 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 And this is your starting point. So therefore this is your result. A, B, C, D, E, F. Okay. A, B, C, D, E, F.
So can't A, B, C, F, E, D come?
A, B, C.
F, E, D.
Because after you visit C, you need to when you have multiple options, you need to traverse this ascending order, right? Because F is bigger than D. That is why I told you you need to use a logic I mentioned. When you have a tie or when you have multiple options, traverse the low value. So I gave you that condition. So therefore, you can't traverse to F. When you have three options, you need to traverse to D. Okay. Right. So that is called depth first traversing. For example, if you had another node here, somewhere here. So then you go like this, say that node is G or H or something. So then you go there, and in the return trip, you need to traverse this. In the return trip, you need to traverse this. Okay. Because at the end, you need to traverse every place, every node. Okay. Actually, this is easier than the traversing in trees. Okay. Just you need to keep track of which node you have already traversed. Okay.
The
Yes.
is that pre-order traversing and depth first traversing are same?
Can you repeat?
Is that pre-order traversing and depth first traversing are same?
There's nothing called pre-order traversing for graph because these are two different concepts. So this pre-order, in-order, post-order is for trees, right? But this is graph. So therefore, those are not related. Okay. Actually, the pre-order, in-order, those are pretty much depth first traversing techniques, but depth first can be done in different ways in trees. But this is just depth first traversing. Okay, just depth first traversing. Right. Now, how do you implement this? How do you implement this? For example, you try to go as far as possible, right? Go there, go there, go there, and then you come back, and then go there, you come back, then go there, go there, go there, come back, and go there, and come back, and you're done. So, how do you do this? Remember, you try to go as far as possible. And when you have run out of options, you need to just come one level back and see whether there are other options to go. Okay. If not, only you come back. So, for example, if in this particular graph, if there's another node connected to this called F, then you go from A to B, B to F, F to H, then you need to come back, right? Because nowhere is to go. So then you need to go E. Then nowhere else to go, you come back, then you go to C and so on. So you can see when you visit somewhere and if there's no way to go, you need to come one level previous and see whether are there any unvisited. So then you visit there. But maybe that is further connected. Again, you come back. So which data structure is going to work? Keep track of this kind of a strategy. Because if there's no way further place to go, you just need to go one level previous. So that is stack. So last in, first out. So if nowhere else to go, you get out of this. So you get back to this point and see whether are there any unvisited things. Right? So then you go there and see whether unvisited things. Then go there. Yes, unvisited things are there. Right? So nowhere else to go. Then you see whether are there anywhere else to go there. Yes, maybe. So therefore, which data structure is going to work? Help stack data structure, because that is where you just uh, pop it and see your immediate previous guide and see whether anywhere is for you to visit. So therefore, in order to program this, you can use a stack. You can use a stack. Okay. Is it clear? Now your task is draw the stack. If you do the visiting using a stack, your task is draw the stack. Because in second paper, sometimes examiners have asked you to draw the stack. Now, initially, what is in the stack? A. Now you visit B. Now this is output, okay? A, B. Now your stack has B. Now your stack has B. Right? Now you can visit F. Now this is the stack. This is the output, okay? So then you visit H. Make sure you put H into the stack. Now from there, you have nowhere to go. So therefore, you need to pop this. Pop. Last in, last out. And check whether is there anywhere to track visit. No. So therefore, you must again pop. Now you are here. Anywhere to visit? No. Pop it also. Right. So now you are in A. Anywhere to visit? Visit unvisited node, right? B is already visited. Yes, C. Right. Now you can put C into the stack because you visit C. Nowhere to visit. So then you come back. Yes, you can visit D. So then you can visit D. And then you can visit I. Now you need to get back. Pop it because nowhere to go means you need to pop it. A, D, G. So then G also pop because nowhere to go. A, D. So then nowhere to go from D. Pop D. From A, do we have anywhere to go? Yes, C. Then put it there. From E, do we have anywhere to go? No, then pop it. We just have the A now. From A, do we have anywhere to go? No, then pop it. So when the stack is empty, you have finished your traversing. You have finished your depth first traversing. Okay, so this is the stack. Yeah. Is it clear? So if someone asks you to give you a graph and asks you to write the output, you must be able to write the output. And ask you to draw the stack at different levels, stages, you should be able to draw like that. Right? So we can say this is visit or pop. Visit means basically push. Okay. Or you can say push and pop. Visiting means push or pop. Whenever you push, it's in the output. Because when you visit something you push it. Pop means you are in the return tree. Anything else you want to explain? You want me to explain? So that is how you implement it. Right? So if you have a stack, maybe you want stack or stack created using Java. Okay. You can implement this. Okay. So this is the pseudocode. Sometimes they ask you to write the pseudocode. And here we need to keep track of whether a particular node is visited or not. For example, when you come back here, you must know that I have already visited B. That is why we are visiting C. Okay. So you need to keep track of that. So that is why in the implementation, in the vertex class, we keep something like, because that is for our processing only, Boolean variable is visited. Is visited for each and every vertex. Okay. And by default, it must be false. By default, it must be false. By default, anyway, it's false, right? In Java, instance variables, integers initialized to 0, Boolean initialized to false. So therefore, you don't need to specifically mention it, right? But if you want, you can say it's false. But whenever you visit, you need to make it true. Make it true. Okay, so let's make it initially false. But anyway, it's automatically that is the case. Okay, is it clear? Because you don't visit the same node twice. So visit 0 node, then push it to the stack. 0 node means your starting node. While stack is not empty, examine the vertex at the top of the stack using peek. Find an unvisited neighbor of this vertex, the first neighbor in that order. Then you visit that. Visit that means you push it, right? You push it, and then you keep doing this because you push that and visit that, and then from that point you push it, visit, right? So whenever you visit, you need to push it to the stack. But if you can't find the unvisited neighbor, you need to pop. You need to pop and continue your loop again. Continue your loop. So again, you check whether there are unvisited things. If so, you visit your next node. If not, you pop. Either you push or pop. Okay. Always either you push your next unvisited one or you pop yourself. You do this until your stack is empty. So when your stack is empty, you have visited all the nodes. Possible, if possible. Okay. Right. So this is how you write it. Anyway, in the exam, they don't ask these kind of things. Okay. First, you need to, let's call it depth first traversing, DFT is challenging. Okay, මටත් බාර දීන්න පුළුවන් දැන් මේ කෝඩ් එක ලියද්දි. කමන්න ලියලා බලන්න. DFT. අපි ගාව graph එක තියෙනවානේ. ඔව්. Say void depth first traversing. Okay. You need to tell the starting point, right? මෙතන අපි starting point එකක් අරගෙන නැත. ඇයි ඒ? මෙතන මෙයා ගිහිලා තියෙන 0th level එකකින් ඉඳලා තමයි traverse කරලා තියෙන්නේ. හරි? අපි මේ විදිහට කරමු ලේඩි ලේසි වෙන්න. හරි? ඒ කියන්නේ 0th index එකේ තියෙන vertex එකේ ඉඳලා තමයි මම traverse කරන්නේ. හරි? ඔයාට ඕන තැනකින් පටන් ගන්න නැහැ. Right. First we need a stack. අපි Java වල තියෙන stack එකම පාවිච්චි කරමු නේද? අපි ගිය පාර පාවිච්චි කරන්නේ දෙන්න stack එක. අද පාවිච්චි කරමු stack එක. Let me take that. කති link list එකක්ද? That is just to make me life easy, okay? 25 semester 3. That is 25 semester 3. This one.
So we used Q.
There we use Q, right? Do we have stack in do you have a stack in Java? Yeah, should be, right? Java stack. No, Java util stack, right? Let's ask ChatGPT to give a code base for that. Or else we can use our own stack. Simple Java code demonstrate using stack. Yeah, you can create a stack object. Then you can simply push and pop. Push. Can we pop? Should be right. Okay, let's see. Stack. And so let's create a stack. Stack. I will use Java util stack. Say char. Sorry, we are going to add what? We are going to add the index, okay? Index. This is hard coded because the first one is 0th element, okay? But later we are going to, there is the stack, yeah. We are going to use the correct vertex, okay? Vertex number, okay? Right, so then this is my stack, int stack. I think we need to go for integer. S equal new stack. Okay, so it has been imported. Yes. Right. So first we can load our zeroth element, assuming that this graph is not empty, right? As a starting point, we can push that. Okay, push that and push that, and also we are going to display it, because if you visit a node, you need to show the label. Okay, you need to show the label. So, and also in the vertex list, that element we will mark it as true, is visited true. Okay, so what is our vertex list? Vertices. Okay, vertices. So in vertices, zeroth, because we are going to start with zeroth element. Let's assume zeroth element is always there. Dot is visited. So our vertex list has vertex. Okay, it's a vertex. Is visited equal true, because we are visited. But before doing that, let's display the label. S out. Let's say print. Vertices 0, because we are going to start with vertices 0 dot label. Okay. Rather than separate method, I just print the label. Right. So now we have visited the 0th element. Remember, in our example, our 0th element is basically A. Okay, A. Now what we can do? Now this is done. Now you need to push the 0 into the stack. Right? We are working in the index level. Okay, 0th vertex we have visited, because we are starting from the 0. So therefore we are going to push it. Right? So our S dot push 0. Now you need to check from 0th position, are there any unvisited things? Right? In our case, we have 1, we have 3, we have 4. Right? Because we have 0, 1, 0, 3, 0, 4. Remember? 0, 1, 0, 1, 0, 3. Do we have 0, 4? 0, 1, 0, 3, 0, 4. Where is 0? Ah, yes, 0, 4. Okay. So that is what we are going to check. Do we have any unvisited connected nodes from 0? Because we are going to visit one of those, and we are going to take the smaller value. Right? Okay, we are going to take the smaller value. In this case, it must be 1. Okay, have I put it the correct things? A, B, C, D, yes. Alphabetical order and numeric order is correct. So therefore, no issue. Okay. Right. So now what we are going to do, we are in a while loop as long as the stack is not empty. Okay. So let's do that also. While this stack, see whether there's a method to check whether it's empty. No method. Right. Let's ask ChatGPT. So this built-in Java class. How to check if this stack is empty. Maybe we need to get the size. There's a method called isEmpty, right? IsEmpty. Yes, isEmpty. Right? As long as it is not empty, we need to do this. right? As long as it is not empty, right? So if it is not empty, now we need to check whether there are unvisited nodes, right? There are unvisited nodes, right? So we can peek from the, right? So we need to write this method then, right? Yeah, we need to write this method. So in this method, what we do is we check whether there are any unvisited. We need to first write this, okay? We check whether there are any unvisited edge starting from that label or zero in our first case, okay? How to do that? In adjacency matrix, we are going to check whether this V dot Vj is 1, where your V is, we have given J is going from 0 to number of vertices. Because if you are in the 0, we are checking whether we have 0, 1, 0, 2, 0, 3 or anything, where the second element must be. So for your first element is this one. Other element, this element to other element must be 1. So if you are starting from 0, we are looking for whether we have 0, 1, 0, 3, 0, 0, 2, 0, 3, 0, 4, etc. where is visited is false. Is visited false means yes, there's a direct edge from your node, current node, that you push it to the stack, which is not visited, right? Because it's in the ascending order, we are getting the first one. Okay, we are getting the first one. Is it clear? Right. So let me copy paste this code. So this is the critical logic. This is the critical logic, okay? Where you find whether you have uh, any unvisited node from that node, okay? So here, not n-words is our current, no, not current. We need to keep the, current number of vertex, right? Max number of vertex is there. Current number of vertex we have not, we have tracked that too. So not the current number of vertex, what we need is max number of vertex, right? What is n vertex? Yeah, current number of vertex is okay, because if you have 10, if you have 10, the maximum is 10, right? We can use that. We can use that, yeah. So therefore, let's use current number of vertex there. If current number of vertex is 10, you are going from 0 to 9, right? 0 to 9. Remember, if current number of vertex is 10 means you are going to 0 to 9 only, right? So then using our adjacency matrix, in our case, it is ADJ matrix, from V to J, right? Vj, because this is our starting point, right? But J goes, we are checking from 0 to current number of nodes in the second index, okay? And also this adjacent matrix, right? It must be 1, okay? And is visited must be false, right? In our case, is visited is this is visited. Both must be satisfied, right? That node must be there and is visited must be false. So why don't we get it? Adjacent matrix. No, this should not be adjacent matrix, okay? This is our vertex list. Vertices, right? Sorry, vertices. Right? Its is visited must be false. Okay, its is visited must be false. If so, we return this. The first one we are returning because you don't need to check the next. The first one we are getting is in the ascending order. If you exhaust your for loop, then we return -1. The -1 means there's no where else to visit from that current node. So that means you are supposed to pop, right? You are supposed to pop. Now we can call this method. Okay. So let me copy this, otherwise I will make a mistake again. This should be inside your while loop, as long as it's not empty. Right. So what we do is, remember we wrote this method, get adjacent unvisited vertex. Right. So how to get that? Don't push it, don't pop it from your stack, right? You just peek it, right? Because you to pop it if there's nowhere to visit. So therefore, don't pop it, just peek it. Just peek it. Yes, peek method is there. Okay. And if it returns -1, that means you have nowhere to visit, no other node to visit. So that means you are supposed to pop. You are supposed to pop. Okay. So that means s dot pop. But if you don't get -1, that means yes, they have given you the next node to visit. This method has given you the next node to visit. So then you need to mark that as visited from your vertex list. Okay, from your vertex list. That is your vertices list. That vertices list has the vertex objects. So you need to mark that as yes, I have visited. Okay. And then you need to display, or maybe you display and say visited. Okay, so how to display? Rather than display, we just print it as out vertices v label dot label. And remember earlier also we use print and make sure you have a space or something like this at everywhere. We are going to print it in the same line. Okay. So you mark it as visited 1 because initial all are false. So then you need to push that value, that one, because you visit and push it. Okay, visit and push it. That is our s dot push your v that return by get, because it has returned you the index. Okay, right, that's it. Hopefully it work. And here after visiting everything, you need to reinitialize your stack because now you have modified your is visited. Next time when you visit, it must be all false, right? It must be all false because now you have finished your visiting. So this is cleanup. Cleanup. Each and every node is visited, you need to make it false again. So that next time, otherwise next time your visiting is going to be giving some issues. Okay. So this is just cleanup code. Okay. So that next time it works properly. So that is after the while loop. Right? After the while loop, you just clean up. So now n words, in our case, it is current number of vertex. Our vertex list, one-dimensional list. For each object, we set the is visited to false because we have set it to true while we are traversing, right? Some of those, this is cleanup. Right, now let's see whether it's work. Hopefully, okay. If not, we'll fix it. Right, so now let's do G dot DFT, depth first traversing. So what we are supposed to get, let's see what we are supposed to get. This is sort of a actually this is a directed one, right? So what is the output we are expecting? We start with A. From A, I can go to B. From B, I can go to C. Then I need to come back. I need to come back. Okay. So then I have D and E. D is smaller, therefore I should visit D. From D, I have F and G. F is smaller, small index, right? So therefore F. From F, I can go to G. From G, nowhere else to go because this is visited one. So come back, come back, come back. Then I'm supposed to go to E. And G is visited. So therefore I'll come back, and by this time A must be empty. Stack must be empty, and that should be the end of the story. So it must be A, B, C, D, F, G, E. Okay, let's see. Hopefully. Not hopefully, right? It's either we have made a mistake or it should be A, B, C, D, F, G, E. Or else we have bug. Or we will get some runtime exception or something if you have made a mistake. Like array index out of bug. Right. So what we get is A, B, C, D, F, G, E, correct. Why B is there? Maybe I use print ln. Maybe I have used a print ln. This is print. Yeah, so this should be print. Okay. And so it looks like our logic is perfectly working. Let's double check. A, B, C, D, F, G, E. A, B, C, D, F, G, E, correct. Right? So see whether you can build this logic by yourself, okay? And right, it's not rocket science, but bit of serious thinking, right? Anyway, I just use the Java stack also. So if you can think of a solution, converting to code is not the hardest thing. The hardest thing is come up with a solution to the problem. Easier thing is convert it to code. Convert it to code. Okay. So the more you data structures, more algorithms you learn, so you have more and more ways of thinking, right? More and more ways of thinking. Okay. Right. Is it clear? Right. They are not going to ask this in the exam, but they can ask something like showing the stack, given the graph, ask you to write the depth first traversing nodes, and so on. Okay. Thanks. So that's why I'm taking a lot of time because I don't want you guys go to final year and නේද දුක් විඳිනවා බලලා මට එපා වෙලා තියෙන්නේ. දුක් විඳිනවා බලලා final year එකේ ඉන්නවා. හරි ඒස් වැහි වස්සපු ස්ටුඩන්ට්ලා. ඒස් වහි වහලා රිසර්ච් ෂීට් එකේ හැබැයි වැඩක් කරගන්න බෑ. ප්‍රොබ්ලම් එකක් සෝල්ව් කරගන්න බෑ. හරි. එරර් එකක් ආවම නේද? චූ යනවා. හරි. ඉතින් අර software development වැඩ ඉවරයි. final year project එකක් තියෙන හොඳට මතක තියාගන්න. එක්ක ඔයා ජීවිතේ පළවෙනි හරි මොකක් හරි තක්කඩි වැඩේ කරනවා ෆයිනල් එකේ. එහෙම නැත්නම් ඔයාගේ ජීවිතේ රෙස්පොන්සිබල් විදියට ගත කරන්න ඉස්සරහට යනවා. හරි. ඒතකොට එකක් තක්කඩි වැඩ කරාම දෙවෙනි වැඩේත් කරන්න පුළුවන්, තුන්වෙනි වැඩේත් කරන්න. එතකොට IT ෆීල්ඩ් එකට යන්නේ නැහැ. ඇත්තටම ඔයා තක්කඩි ෆීල්ඩ් එකටම යන්න බලන්න. හොරකම් කරන, ජරාව කන, බොරුවෙන් ජීවත් වෙන. මොකද බොරු කරන්න පුරුදු වෙන්නේ ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එකේ. තමන් වැඩේ කරගන්න නැතුව. දැන් විභාගෙදී හොර කරන්නේ නැහැ නේ ඔයගොල්ලෝ නේ. විභාගෙදී ඔයා ගිහිල්ලා ඔයාගේ නොලෙජ් එකෙන් ලියනවා. නමුත් ප්‍රොජෙක්ට් එකේදී එහෙම නොකරනවා කියන්නේ මොකද්ද? ඔන්න ලැජ්ජ බය නැති කළා දාන්න. හරි හොර වැඩ කරන්න. මොකද ඔයාගේ දිහා බලන් ඉන්නේ සමහර මිනිස්සු සුද්ධවන්තයෝ අනිත් අය බලන් ඉන්නකම්. අහක බලාගත්ත ගමන් ජඩයක්. Right? So don't get into that. Right. So that is depth first traversing. Okay. Right. Our next one is breadth first traversing. Breadth first traversing. So in breadth first traversing, we try to stay near the current visiting node or starting node. Okay, current node or the starting node. And when we have no near points, then only we go to the first node we visited, and from there you check are there any other node to visit, because we have no other place to visit from current node. So now you can see obviously we need to use what? Q, because the first node where we visited at this level, now we are going back to that. So therefore stack is not going to work. We are going to use, or we are supposed to use a queue for that. Okay, right. So let's first do a breadth first traversing. Right. So this is our graph. Okay. Assume this is our starting point. So this is my A. From A, I can go to B. If there's a tie, we'll go to the ascending order. So then C, D, E. Now I don't have any other place to visit directly from A. So then I check what is the first one I visited. Can I visit somewhere from at least that point? Yes, you can visit F. But you don't go further, then it is death first. Single level, can I traverse anything? No. So then what is the second place I visited while I was in A? C. Is there anything to go? No. Then what is the third one? Yes, D. Yes, I can visit G. Okay, G. So then from A, I visited D. Can I visit anywhere from E? No. So that means this level is now exhausted. So then in this level, I first visited F. So from F, can I visit somewhere? Yes, H. And G, can I visit somewhere? Yes, I. Right. And now I need to come back to from F I first visited H. Can I go anywhere from H? No. Can I go anywhere from I? No. So then that's it. So therefore, this is your final answer. So this can be done using a queue. Right? Now, can you draw the queue for this visiting, breadth first visiting? Can you draw the queue? Just like earlier we draw the stack. Now earlier when you visit somewhere, we push it. But here when you visit somewhere, you don't put it into the queue. That is very important. When you visit, don't put it into the queue. Okay? Just visit. So therefore when you visit a, still your queue is empty. Right? I mean at the beginning, right? Sorry, only in the beginning. Right? Other places, yes, you visit, put it into the queue, but at the starting point, don't put it to the queue. Okay. So therefore, you just visit A. So then from there, you visit B. So this is your queue now. Now you have already visited A and B. Then you visit C. Put it there. Right. If you are going to take it from here, you can put it there. Then this is front, this is end. Okay. So B and C. This is my front. If I take something, I will take it from here. Okay. Then I visit C. Sorry, then I visit D. Then I visit T. This is my queue. Right? Now I have nowhere else to visit. Nowhere else to visit. Now your task is DQ sum, DQ. Right? DQB and see whether you just DQ, right? Because this is return tree. So then you have C, D, E again. And see whether can you visit in single step somewhere. Yes, you can visit F. You visit F. and put it into the queue. C, D, E, F. But nowhere else to go. If you have anything else connected like this, yes, you can visit. So then you are exhausted. Then yeah, therefore you need to DQ another one. Right? That means you need to DQ C. Right? DQC. So then it is DEF. And see whether you can visit somewhere. No. Then you need to DQ again. Okay. That is now your EF. And can you go anywhere from there? Because you DQ D. When you DQ, you need to check whether you can go somewhere. Yes, you can go to G. You can go to G. And you NQ it. So nowhere else. Nowhere else. So therefore you need to DQ your E. And nowhere else. So therefore you need to DQ your F. And see whether can you visit somewhere from F. Yes, you can visit H. Then you NQ it. Nowhere else to go. So then you need to DQ your G and see whether you can visit somewhere. Yes, you can visit I, but nowhere else to go. Right? So therefore you need to DQ H and see whether can you visit somewhere from H. No. So then you have no other option, DQI, and see whether you can visit somewhere from I. Nowhere. So then of course you are empty and you don't have anything anywhere to visit. So therefore that's the end of the story. You have already visited. Cease your visit. Okay. That is how you do it. Make sure that your first one is not NQ'd. First one, right? All the other places, whenever you NQ, whenever you visit, you NQ it. But first one, don't NQ it. Okay. That is how you do it. So if you are given a question, you must be able to draw the queue. Because that is what the examiners can ask rather than asking court. Okay. So now can you implement it by yourself? Again, you need to keep track of is visited and at the end you need to clean up that. Clean up that. Now you need to use a queue. You can use a Java queue. Java queue and do it. Right. I want you to do it by yourself. Okay. I want you to do it by yourself rather than me doing it. Okay. So just code it. Maybe in the evening, I will give you the code. Breakfast traversing also completed. But now I am not going to give you that code. Okay. Because I want you to do that code and test it. Now, by the way, if you do a breakfast traversing for this one, what should be the output? Can someone, okay, take 2 minutes and write down the output for breakfast travel because you can then test it after you implement it. Right? Write down the sequence after doing breakfast traversing. I don't need the queue. Queue, you can write it later, but just the breakfast traversing output. Everyone must do it, okay? Everyone. Now, when you are doing your final year project, you have all the help in the world, right? You are not in an exam paper. Now, the funny thing is, when you are isolated in the exam hall, you get A's, A pluses. When you have all the freedom, right? Get any help from anyone, you can't do your work. and you try to buy your software. What kind of funny thing is that? Right? You can get help from ChatGPT, you can talk to others, but at the end, you must do it. Right? You must do it and you must defend your product. So there you are helpless. Right? Because in reality, you can talk to others, you have the internet when you go for a job. So do you have the internet? So when I got my first job in 2000. At that time also, 24 hours we had internet. 25 years ago. Most of the guys in Sri Lanka, they don't have internet, but we have. We have internet, we can chat to anyone. හරි. අවුරුදු 25කට කලින් අපිට ඒ දවස්වල පාවිච්චි කරේ MSN එකෙන් තමයි ළඟින් ඉන්න යාළුවා එක්කත් chat කරන්නේ. ඒක අපි යම් මචං කියන්නේ. US වල ඉන්න team members ලා එක්ක chat කරන්නේ. ඉතින් එහෙම ඉන්ටර්නෙට් නැති කරන්නේ නැහැ ඔයාලට. ඔයාලට කවුරුත් කියන්නේ chat GPT use කරන්න බෑ. කියන්නේ මොකද? මේක develop කරලා දෙන්න. මේ වැඩේ කරලා දෙන්න අපිට. ඔයාලට පඩි දෙන්නම් අපි. ඒක කරගන්න බෑ ගොඩක් අයට. අහන්න ඕන ප්‍රශ්නයක් තේරෙන්නේ නැහැ chat GPT. නැත්නම් ඉන්ටර්නෙට් එක සර්ච් කරන්න ඕන විදිය තේරෙන්නේ නැහැ. මොකද ඔයාගේ ළඟට ඇවිල්ලා සීල දේ කරලා දීලා යන්නේ නැහැ නේ කවුරු. ඔයාට ඒ tools පාවිච්චි කරලා වැඩේ කරන්න. You need to develop the system. You get all the help. දැන් මම සැරින් සැරේ දැක්කම මම කිය stack code එක එහෙම තමයි help කරන්නේ. නැත්නම් ඔයාට A to Z software එක ලියලා දෙන්නේ නැහැ. Of course, these are well-defined problems. You can even ask to implement the depth first traversing, but your final year project is not like that. And it involves various technologies. You need to set up your servers, so many things. How do you get that confidence? Gradually. ඉස්සර මේ වගේ චූටි දෙයක් කරගන්න පුළුවන්ද බලන්න. මේ වගේ චූටි දෙයක් කරගන්න බෑ නෝ ෆයිනල් ප්‍රොජෙක්ට් එක කරන්නත් බෑ software develop කරන්නත් බෑ. ටීම් එකකට ගියොත් එම් ගහලා එලවනවා. හරි. බාලාන්ස් වැඩ කරන්න බෑ කියලා. හරි. Right. So let's start with A. A. From there, I will visit B. From there, I will visit D because D has lesser index and also D is in the alphabet before E. Right. So then I will visit E. Now A, B, D, E. Nowhere else to visit in single level. Okay. So then I will check whether now I have visited A. I have visited B. I have visited D. Now is visited කියන boolean flag එක මේවා false වෙලා තියෙනවා. True වෙලා තියෙනවා. Right. So then I first traverse B. From B can I traverse in one level? Yes, C. But that's it. So then I next traverse D. From D can I traverse somewhere? Yes, G is there. F is there. F is smaller. So therefore I'll traverse F. And then I can traverse G because G is also in the one level. So then I have nowhere else to traverse from D. So then from E, nowhere else to traverse because G I have already traversed. From C, nowhere else to traverse. Right. F, nowhere else to traverse. Okay. And also now from G, nowhere else to traverse. So therefore this should be the output, right? A, B, D, E, C, F, G. Right. A, B, D, E, C, F, G. Correct. Yeah. Okay. A, B, D, E, C, F, G. Correct. So that should be the output. So test that. Okay. After writing your code, say BFT, beat by breadth first traverse, and see whether, because now we already have the test data. Right. Test data. See whether you get A, B, D, E, C, F, G. Okay. Right. So that is a must. You must implement it. ඒ වගේ චූටි අභියෝගයක් බාර ගන්න නැති කෙනෙක්ට ජීවිතේ අභියෝග නම් බාර ගන්න බැරි වෙයි. විශේෂයෙන් software development වගේ career එක ගිහිල්ලා final year project එකේ අභියෝගය දැක්කමත් හරි දුවයි හරි දුවන්න පටන් ගනි. Right. So any questions? I will share the current code because we are not going to do any more coding. But maybe in the evening I will give you the coding for other method also. But by that time you must have already coded and tested. Okay. Stack tree graph. So I'll give you the full code. Earlier code also here. Okay. Right. So we'll take a break. After the break, first we want to do communication skills, right? So there's a small part, but first, otherwise every day we could just keep doing data structures or distributed databases and we don't do the communication skills. So therefore, first after the break, we need to do a communication skills session. So then if we have time, we can come back and finish because we need another half an hour to finish. Okay, so let's continue. Our next topic in communication skills, I think we did not do communication skills for very long, but we want to finish that subject also, right? Remember, if you fail communication skills, you can't go to level 3, right? So you know that. Right? So therefore, don't take it lightly. Right? Technical writing and effective communication. So that is our next subtopic. This is very important topic for the exam. Very, very important topic for exam. A lot of questions will be from this topic, okay? Right, technical writing and effective communication. So remember when you are doing IT, if you get into the technical field, right, you also not, it's not just writing, developing systems, right, managing systems. You may need to prepare reports, technical guides, user manuals, help systems, and so on as well in some time to time. Right. So overview, this section will introduce aspects related to technical writing and effective communication. Further, it will give you insights into the tools which make the technical writing process easier. Additionally, the section introduced few technical documents, knowing of which would help during and after the degree program. So intended learning outcomes, express concepts, ideas, proposals effectively to different audience, stakeholders in a given context, employ various tools and technologies in aid of effective professional and technical communication. Okay. Right. So this is all about written communication, not oral communication. Right? Whether it's written or oral, there are common factors like your clarity, simplicity, relatedness, and so on. But when it comes to presenting, so there are some other aspects like formatting and so on as well. Okay. Right. So you can use different tools, right? Starting from simple word processor. If you are preparing a presentation software, right? And any other tools, especially word processors. Right? So we can categorize them into authoring tools, screen capturing and annotation tools, picture drawings and image editing tools, because sometimes you need to prepare your own images, edit images, and publishing tools. That is, you publish your documents and so on, and also content management and so on. And some of these are free and open source, some of these are commercial tools. Okay, right. So authoring tools, right? So you can start with pen and paper, and it can expand into digital documentation. These days, very rarely we write things using pen and paper, right? Unless you face an exam or something. Most of the time, we now prepare documents using electronic documentation. So therefore, when you select your tool, you need to consider a few points, right? What is the cost? Like some tools are free, some tools you need to get the license fees. Uh, what kind of imports and exports? Because maybe you already have a document. Can you import it to that tool? And can you export it to the expected format? Because otherwise you are in trouble. And also, what are the productivity features available, like grammar check, spell check, reviews, automatic TOC generation? Is it support teamwork? Because most of the time, especially these user manuals and so on, it's not one person, set of people collaboratively uh, edit it, right? Especially version controlling. So then it is cross-platform support. Maybe you use Windows, another guy use Linux, Ubuntu, another guy use uh, Apple Mac, and security and other permissions. Can you encrypt it? Can you password protect your document? Right. So it depends on your requirements. Okay. So let's take one by one. Cost of ownership. That is how much you are going to spend for that tool. So which includes the licensing fees. Sometimes you don't need to pay for license. Sometimes you need to pay for that. The cost of hosting, if it is a cloud environment, sometimes you are supposed to save the document in the cloud itself. Maybe you need to pay additional payments for that, right? Cost of keeping, whether they provide a free storage or you need to keep it in your own machines. Cost of backup, especially if you have a lot of documents. And if you need any other additional features, plugins, do you get it free or do you need to pay for those additional features? Okay, and so on. So then import and export. First, can I import my existing documents to this tool or part of tool, right? For example, say you have a PowerPoint and you are moving for another tool. Can I directly import my PowerPoint to this tool and start editing? Can I import my images? Because sometimes there are restrictions. Can I use my templates? And also, can I export it to the expected format? Can I export it to PDF, like HTML, using this tool? You need to consider those. And what are the productivity tools and features available? Is grammar check available? Spell check available? Automatic TOC available? Header footer? Okay. Version control support is there. Reference management, linking, and does it support teamwork? That is especially version controlling, so that you can lock your document, check in, check out, merging. And also, does it support workflow-based collaboration? Like one person add contents, the manager need to maybe manager need to approve it, approve that change. That is a workflow. So maybe another manager can publish it. Can you do? It doesn't mean that always you need. For example, if you prepare everything by yourself, of course you don't need this, right? Say final year report. It's everything is done by you. So then you don't need teamwork support for that. But maybe your career, right? You are preparing a help document. Maybe it's a teamwork. You need that kind of support. So then cross-platform support. Does it allow you to use it in different OSs and so on? Is mobile support is there? And of course, security and permissions. Can I password protect? Can I encrypt it? Can I prevent editing that? Can I prevent even printing that some cases? Right. So then they have given, this is very important things. A lot of questions will be there from this, at least about 2 to 3 questions every year. That is, there's a tool called LaTeX, which is a very boring tool, by the way. But anyway, whether it's boring or not, you need to familiar with that. Actually, you need to sort of master that. But I'm not going to do it today. So I want you to download LaTeX tool and see whether you can learn it by yourself. Right? It's basically sort of a very primitive, like notepad-like tool with some tags and so on. Right? You prepare your structure of your document, which is very boring tool. Very rarely people use it. But I will do a separate. I will do a session on LaTeX. But before I do it, I want you guys to download and get a little bit of familiarity, or maybe try to self-learn LaTeX by yourself, how to use LaTeX to prepare a document. So at the end, it generates the PDF version, but it gives you a consistent styles and so on, table of contents and so on, right? Very rarely people use it because all these features are now available in more sophisticated tools like Word, writer, and so on. Anyway, I will do this in a separate session, okay, taking about half an hour. So I'm not going to do it today, but this is good time for you to get familiar with LaTeX by yourself, okay? So it support version management, centralized styling, reference management, some math equations and so on, annotations. Okay, so those are some additional support. You need to remember these also because they ask what are the features available in LaTeX. And more than that, how to do certain things using LaTeX, right? How to add a heading, how to generate a TOC, and so on. Okay. Right. Anyway, we'll do it in a separate subsession. Okay. So this is how you install. And YouTube, there are a lot of resources you can use. Okay. Right. I'll take it in a separate session. Right. Make sure you pay attention to these subtopics. How to add a figure, image. It's not just drag and drop. It's more primitive level tool. Okay. How to add a table. How to add references. Okay. Even examine. They have given you the YouTube links. Right. So we'll take that as a separate topics later, not today, this separate day, because I just want to finish the theory part first. Okay. Right. So then technical reporting. So technical reporting means you give a report, technical report for your final year project. Also, you are supposed to provide a report. It's a technical report. So your technical report may includes preparing the software requirement specification, SRS. Okay. Maybe design specification. So those are technical reports. So here you have all the requirements, use case diagrams, and so on. And design document, okay. Technical manuals. So those are all technical reporting. Sometimes you just need to say this is a technical manual. Technical procedure means how to use it. What is the procedure for use or do certain tasks? So then these are supposed to be used by technical people like operators, right? Other technical people, because they refer to your manuals, procedures to understand how to operate it, how to use it. So these are the typical contents. It doesn't mean that every technical procedure has these, right? Purpose, safety, especially if it is mechanical or electrical type of things, some preconditions, maybe qualifications of those who prepare this document, list of materials, list of tools, step-by-step instructions. So these things can be even simple things like doing a regular maintenance of a vehicle, doing a regular maintenance of a AC. Those more complicated things. So then the user manuals. So user manuals are also sort of a technical report, but it's less technical because we target the end users. But sometimes some tools and so on are fairly technical to use as well. But you need to go into a little bit less details, make it less technical when it comes to user manual because your audience is wide enough and their purpose is slightly different. Maybe they are not doing any maintenance tasks. Maybe they just want to operate it. Right. So they have even taken CV or resume also as a technical writing. It's technical writing. Right? Right. So what is the difference between CV and resume? Resume is a shorter version, just like usually one page. CV can be little bit longer. When I say longer, don't think that CV can be 10 pages, right? So if resume is one page, maybe CV can be two page or maximum three page. Sometimes the job posting say send a resume. So then make sure you send a short version, resume. Sometimes they will ask send a CV. So then you can send that longer version. So ideally you should have your own resume and CV. Especially HR department prefer resumes because they don't want to go into details. They can go into the details in the interviews. But sometimes they expect CV, a little bit more detailed view before they ask you to come to the interviews. Okay. So here it's common contents, right? So your resume must be short, ideally one page. Okay, just one page. So in one page, you know that you can't write a lot of things, right? Just up to the point. Simply your name, contact information, like your phone number. Optionally, you can have a statement of objective or summary, just one or two lines. That is your career objective. It must be unique thing for you. You can't copy others' objectives, right? And you can specify your experience in reverse chronological manner. That means your latest experience comes first. Because the most important thing for them is experience. Sometimes some people prefer to put education qualifications before experience. Some people prefer to add experience before education qualification. It depends. If you are a fresh graduate, maybe you can take education before experience. But if you have about 10 to 20 years of experience, you better put experience before education because for them, your experience is more important than your education qualification you took about 10 to 20 years ago. It depends, right? For example, if you're applying for architect, for them, your experience is more important than education qualification. But if you're applying for a trainee or associate software engineer, maybe your education qualification is more important for them than your experience because sometimes you don't have any experience as well. So then any other certifications, but make it very brief, right? Just what is your certificate? You can highlight any of your key areas of expertise, technologies, but very briefly just mentioning is enough. Or maybe you can say 0 to 5 scale. Your level of skill is 5 for this technology 4. Okay. But don't list so too many of technologies, just few, maybe just maximum 5. So that highlight what are your core competencies, maybe web development, database, Java or Python, or you can say something like cloud computing, cyber security. Depends on your specialty. Okay. Any other awards, honors, right? If you can have first class, second upper, so why don't you highlight it, right? It's a good thing, right? It shows that you are very classy person. to do things in a high level, but it doesn't mean that it guarantee your job, because some people have first class, but they can't do anything. But having a first class is good. Having a second class is good, but just having the second class, first class is not good enough. Right? Any affiliations with any professional bodies, your references. If they ask, usually these days, very rare they care about references. But in some cases, yes, referees. And try to make it very unique, simple, elegant, and unique. Because your CV, your resume is your personality. Sometimes your resume will determine whether you get the interview or not. Of course, the resume plus your contents. Sometimes you have a lot of good contents, but you don't prepare your resume, right? එන් බලන එක්කනට එහෙම හිතෙන්නේ නැහැ ඒක දැලුවට එන්න කියන්නේ. එන් මෙලෝ රහක් නැහැ සමහරවගේ රෙසියුමේ එක. සමහරවගේ රෙසියුමේ නිකන් අනවශ්‍ය කැටයක්. It's your ඒක තමයි ඉතින් ඒක. ඒක ඔයාගේ personality එක නේ. ඔයා වැඩක් කරත් සමහරවගේ මෙලෝ රහක් නැහැ නේද? කෑමක් හදුවත් මෙලෝ රහක් නැහැ. ඉතින් ඒක it's also part and parcel of your personality, your life. And having a summary is good, maybe objective, but make sure it's very specific to you. It's like your personality in one sentence, two sentences. Right? Your core values. It's like you are doing a marketing. Market yourself. Who are you? But make sure it's very customized, unique, not general things, right? You can see this is not a good one. Almost 6 years of extensive programming experience in various languages. You can see various languages, right? With 5 years of extensive web development, expert in MySQL database design. Now let's see how do you make it a little bit more specific. More than 30 years of experience as an engineer, professional from junior engineer to vice president of technology for a Fortune 500 company. Earned PhD in electrical engineering with over 300 publications and 27 patents in embedded telecommunication. And of course, you may not be having this kind of a statement, right? But try to be specific, right? What is the exact role you play, right? Maybe you can specify your technologies you use, right? And so on. Rather than just give a general statement that anyone can put it into his or her resume. And when you provide your experience, be honest. If you don't have any experience, just accept. No, I don't have any experience. What else to do? Right? Make it very specific. If it is 3 months, 3 months. Place. What is the role you played? Is it a technical thing? Business oriented? And when you have multiple experience, you prepare it in reverse chronological. That means that your latest experience must come first. That is education qualification also like that. Your highest qualification must come first. If you have MSc, first MSc, then your first degree, then your A level. Sometimes when you have those kind of things, sometimes they don't care about your A level, O level as well. Just the degree is enough because you need to put it into one page in resume. Okay. So again, you can see this is sort of a too general statement, a very specific statement. Part of a team that developed a 1 billion weapon system, wrote software acceptance test scripts, and conducted acceptance testing for a 1 billion classified weapon system. Maybe this is a brand name, okay? But this shows exactly what you did in that particular organization. This is your experience, okay? Like any other education, training, certificates, you can highlight, especially if you have achieved something exceptional. And referees, right? Referees. Sometimes they ask you to add referees, sometimes they don't care, but usually still we add referees. But when you add referees, you must be very careful, right? Some people, they are very careless about referees. So if you're adding referees, make sure that guy know you, right? For example, if you want to add me as a referee, right? You know that you guys don't talk in the class. I only talk. So if you guys want to make me a referee, right? Only one or two of you guys I know. Sometimes it's not by name, but if you introduce, I know. But most of you guys, I have no idea, right? Because you don't talk. Because it's online class. So then adding me as a referee is not going to work. Of course, right? So that you need to understand. But if you talk to me, chat with me, then I know it, right? I know, right? At least when you call, I can check the chat history, WhatsApp history, and double check. Because the purpose of adding a referee is if they want, give them more details. And if they are, if someone call me and if I don't have a very good information about you, so that means I am also helpless. I can't help you. That is actually disadvantageous for you. So then the other party will think that, okay, maybe this guy is not good. Maybe it's not, you are not good. Maybe I don't have enough information to tell. So therefore, make sure if you are giving a referees, make sure it's someone who knows you very, very well. Someone who can answer any question about you. Right? So otherwise, you're also in trouble. You're also in trouble. But very rarely they call these referees, but some cases, especially if you're applying for a bank or something, that they call. They always call. Software development field, very rarely. Okay, software development field because they most rely on the job interview. But when you're doing this, make sure you do it in a very serious manner, right? Because otherwise, uh, you're in trouble, right? Or you need to give very good introduction to you. Sometimes people ask, can I add you as a referee? But they don't even send the CV to the, right? So then we have no idea. But sending CV is not the solution, right? Unless we have no interactions, of course, we can't just look at the CV and we can't memorize each and every CV. So the idea is if you are giving references, make sure you know that guy very, very, very well, right? So you know that guy means actually not you know that guy knows you. No point you know that guy can tell A to Z about you. A to Z means some realistic experience working with you, interacting with you. Okay, and that is very important, right? So otherwise, it's disadvantages, right? Right. So that is very important. Right? And these days, most of the time, what they do is they use something like LinkedIn, right? LinkedIn, and then they can see who are the connected people. And again, don't connect to people who are not really connected with you. Then they will call these guys or chat with these guys and ask about you, and they will say, okay, this guy is just a LinkedIn friend. I have never talked to that guy. So LinkedIn is supposed to be your genuine co-workers, right? Your professional friends and so on, right? Sometimes you try to get 1,000 LinkedIn users, right? So then it is disadvantages. If you are working in a small company with five people, if three of them in the LinkedIn, make sure you add those three. Right. So these are some tips. The order of the items matter, right? So maybe you can start with experience, or maybe you can start with your education, depending on the situation, and also reverse chronological, highest qualification first, latest experience first. And also make sure you customize your resume, CV, according to the job you apply. That is super important. Some people, they just send the same CV everywhere, right? Because if you're applying for a, say, Java developer, you can little bit highlight your Java skills. If you're applying for a data science, you can highlight bit of your data science, maybe Python and that kind of skills, rather than highlighting Java or web development. So these are the small things you need to do. Of course, whatever you highlight, you must have it. Right? Highlight your strengths because this is marketing. Market yourself and be honest. So highlighting doesn't mean that you give things that you don't have. You boasting. No, you be genuine. Be genuine. And don't make it a joke or something like that, right? Casual. No, this is serious. This is business. Right? This is business. So be very serious about your CVs until you apply for the job post of a joker. And also just use the normal mode, right? Don't hurry it. No point sending registered post. Who cares? Right? So some people do like that kind of things also. It's thinking that okay, if I send it by registered post, they have no other option but to call me for the interview. No. So they only look at the best people, not how you deliver your CV. Okay. So if they just say online submit. Sometimes they don't even ask you to send a CV, rather they will give you a form to submit. Okay. According to their expectation. Right. So that is very important when you prepare your CV, right? You see preparing your CVs, you market yourself. Then dissertations, that is your reports, right? So your finally also you need to submit your dissertation. So you must know what is the component of for the university guide you and tell you what are the components. You can look at a sample report from previous year students. So then you know the expectation. These are very serious, right? For example, when you prepare your final year report, so they specify what is the font, what is the font size, what are the left margin, right margin. It must be exactly like that, right? What is the expected font size for heading one, heading two? Some students, they don't care. They simply fail. They simply fail. That means they are not serious. They think මේ නිකන් ගෙදර ඉඳලා මේ ලියුමක් ලියනවා කියන එක finally report prepare කරන සමහර. So these are serious stuff in academic level. Your reports, theses, okay. So it must be exactly according to the formats. Otherwise, you are losing marks, or sometimes your reports get rejected. Right? If there are too many issues. So it's very, very important, right? Be very serious about those things, formatting and everything. Right? If you have any doubts, you need to talk to your supervisor, double check rather than you do it in. And it's very important that you, before you submit anything to the university, you give it to the supervisor for review. Because supervisors have experience with these documents as well. So they will tell, okay, these things are not properly formatted. But sometimes what happens is you don't even uh, run your spell checker, grammar checker, and send that to the supervisor. Then supervisor is not going to do anything for you because supervisor is not supposed to fix your grammar issues, spelling issues. That is where you have the tools. So then usually supervisors will not give you any advice at all because you are under the expectation, right? Because first of all, you must give it to your supervisor thinking that now I am submitting this to the university. So the supervisor must have only few issues to solve, not solve, suggest. Sometimes supervisor will say, okay, this is rubbish, right? This is rubbish. No, you can't send that kind of a thing. And sometimes when the submission is 12 in the night, they give the document to the supervisor same day. So you are supposed to give that document to the supervisor at least about 2, 3 days ago. Because supervisor will also take at least 1 or 2 days to look at your document because supervisors have some other work. So those are the things you need to understand, right? So if you're supposed to, if your deadline for submitting a document is Friday, you need to give it to the supervisor at least by Wednesday. Maybe he or she will give it by Thursday. Then you have at least 1 day to fix those issues. Sometimes 1 day is not enough. If there are a lot of changes, sometimes you need at least 3 or 4 days to fix those issues. So those are the things you need to understand, right? Those are things you need to understand, right? So that's because these are very important, right? Be very disciplined. Whatever you do, not only your product. Yes, developing a product is super important, but at the same time, you can't take other things lightly as well. And so, sometimes they are very good at their development, but they are careless in the reports. Some students they only think about the report, they don't develop anything. They think that the report is going to give them the marks. No, you must be serious in both. Okay. Right. So then second part. Right. So this topic has two notes from UCSC. This is second part. So this more points about technical writing. Okay, few points actually. Right. So when you write a technical document, so remember there are different type of writing: technical writing, literature, casual things like you chat with your friends, right? So casual things, technical things, uh, literature, business, technical and business things are a little bit closer because both must be technical, business, and academic things must be formal, right? Technical, business, and academic things. So there, the important facts are like precision, right? Accuracy, clarity, relevant, simple, short. So those are the important facts. Maybe those are the bad things when it comes to literature, right? You are very implicit, right? වියංගයෙන් කියන්නේ දැන් technical writing වල වියංගයෙන් කියන්න බෑ. Business writing up to the point. So don't mix those things. Right? So this is an example of a non-technical writing. An email to your friend or Facebook post. Those are technical writing. දැන් මේකට ඊළඟ වැඩේ. හරි සමහරව Facebook එකේ post දානවා ලියන භාෂාවෙන්. හරියට විභාගෙ ලියපු උත්තරයක් වගේ තමයි Facebook එකේ post දාලා තියෙන්නේ. දෙපැත්තම වරද්ද ගන්න. සමහරු technical writing එකක් ලියනවා. යාළුවෙක්ට ලියන ලියුමක් වගේ. ඊළඟට යාළුවෙක්ට ලියුමක් ලියනවා නැත්නම් යාළුවන්ට බලන්න post එකක් දානවා හරියට අච්චු පොතේ තියෙන ආටිකල් එකක් වගේ. Both are wrong. දෙපැත්තෙම විහිළුවක්. හරි ගොඩක් අය ලියන භාෂාවෙන් Facebook වල වගේමයි ලියන්නේ. හරි ලියන භාෂාවෙන් ලියන්නේ මොකටද? ඒක එතනින් නේ. යාළුවෝට. යාළුවෝ ටිකට ඉන්නේ. යාළුවෝ ටිකට මොකටද එහෙම ලියන්නේ? ඒතර යාළුවෝ ටික බලන්නේ නැති මොකට පිස්සුද කියලා. එහෙම ඉන්නවා. මම දැකගෙන 120ක් 30ක් ඉන්නවා. හරි. ලියන භාෂාවෙන් තමයි post ලියන්නේ, comment ලියන්නේ. ඒතර අපිට දෙන මොකක් හරි නට්වල අවුලක් තියනවා කියලා. එක්ක ඉස්කෝලේදී වැඩි උගන්නලා. තාම ඉස්කෝලේ පන්තියේ ඉන්නේ. Both you need to adjust. Okay. So when you are writing technical things, be very formal. Business things, be very formal. But when you are writing other things, be very casual. Casual. So this is a non-technical writing. Right? You can see, so yesterday I'm driving to the bank on Valley Road, and when this idiot runs stop sign and blah blah blah. Thank God I wasn't hurt. Right? So that is very casual, right? This is fine for casual writing. And this is ideal for casual writing. This is how you should write. But when it comes to technical writing, it must be completely different set. Right? On October 1st, 2017, at approximately 10 a.m., driver A was proceeding by vehicle on Valley Road through a cross street. Driver B means some name, okay? Was proceeding through the stop sign at the cross street, blah, blah, blah. Now you can see it's all of a sudden it's very precise, formal, right? Concise. Right? So you must adjust to the context. So when you do your final year project report also, make sure it's very formal. Right? You are writing something very formal. Use a lot of passive voice. Don't use I. Mama kara ke liye reports. Passive voice. Because everyone is interested in your task, not you. And of course, your technical business writing depends on your domain, your career as well, because you know that the way doctors think and write is different from the way software developers think and write. The way lawyers do their writing. Okay. So it's different, right? Yes, you have your own personality. Your field has a sort of a personality. Right. So this is a classification. Taxonomy means classification of technical writing. Right? When we say technical, it's business, academic, everything together. Okay. Right. So this is one type of technical writing, technical reporting. So that means it's a report. You are reporting something. It's not user manual or something. So then you must know the purpose. Right? You're supposed to report what you have done or what you have seen. Okay. What you have observed. That is the purpose of reporting. Right? This is not user manual, technical manual. So it can be progress reports, feasibility study, right, and so on. But manuals are not usually reports, but it can be a procedure also. Planning documents, you report it. You report a bug, reporting. So you must be specific to your task. Then, of course, the business communication. Remember, resume is a business communication. Cover letter, you are writing a business proposal, you try to solve a customer issue, HR communication, administrative communication about the policy changes and so on. So those are business writing. Or you communicate with your business customers, business partners regarding a project or something. So again, you must be very formal, up to the point, right? Relevant, short, simple. Then scientific writing. Maybe you are preparing a research paper, journal article, or you are preparing an article for a conference, newsletter. So those are scientific writing. Okay. Authority of technical writing. So authority means when you write something scientific, technical, it must be reliable, right? Others must accept your writing. Of course, it depends on your qualification, your reputation. At the same time, in order to make it a little bit more reliable, you can do certain things like you can get it reviewed by peers. Then it's add value to your say thesis, because you can say that this technical writing, this thesis is reviewed by these and these people. So that add additional confidence, add additional value to your technical writing, your uh, academic writing. Okay. And when you review, there are different ways. Sometimes it's you review, sometimes when you submit it to a university or something, the university will do the review before they publish it. So maybe you can do the review. Whether you do the review or not, sometimes the other party will also do the review. Okay. So there are three type of reviews: single blind, double blind, and open peer review. So this very famous question for the exam. The three type of reviews. Right. So single blind means author doesn't know the identity of the reviewer. Say you submit it into a panel, say university or something, then the university get it reviewed, right? So you have no idea who has reviewed your document. Or you submit to a panel of people, you don't know who reviewed it, you know, right? Maybe there are 10 people, but you don't know which guy reviewed your document, your paper. That is called single blind. But that person, the reviewer knows who are you, whose document they review. But the publisher has no idea who reviewed that. So that is called single blind. A double blind means the original author has no idea who reviewed it, and the person who reviewed it has no idea whose article, whose research paper that guy is reviewing. So that is called double blind. Okay. So the third one is open. So that means you know who reviews your document and they know that person know whoever they know that, okay, I'm reviewing this guy's things. That is called open peer reviews. Each other is known. Okay. So there are pros and cons of both, right? Pros and cons. You need to understand what are the advantages, what are the disadvantages. For example, if it is single blind, you have no idea about that guy, but that guy knows about you. Okay. Sometimes because they can give you very honest review comments because their identity is not revealed. Okay. Because they have no pressure about you judging them. But at the same time, they have lack of, actually they have a good understanding about the author, but maybe you have no understanding about their reviews or their review comments, whether it's fair, what kind of person gave that review. Because when you look at the review, sometimes you will be wondering why this kind of a comment is given because you don't know who reviewed it. Maybe it is valid, but you don't care it. Maybe you are serious, but maybe that is not very serious review. So likewise, there are pros and cons. In double blind, so that is the most independent review because both parties are not known to each other. Right? No biases at all. Sometimes when the reviewer has no idea about the background of the original creator, sometimes it will be difficult for them to review because they have very little insight, right? Very little insight about the person who made this thing. Sometimes it is good, sometimes it is bad. Okay. Right. So these are the basics when you are doing a technical writing, like reports and so on. Right? Structure your writing. Identify what is the structure you are going to have. It depends what kind of thing. Is it a thesis? Is it a research paper? Is it a conference publication? Is it a normal report for your project? So then you must know what are the expectations. Sometimes the structure will be already there. Make sure you prepare it according to the structure. Okay. Whether you need introduction, whether you need, if it is software development type of project, like analysis design. If it is user manual, it's a different structure. Know your audience. So this is very important, right? For example, one of the biggest mistakes students make when they prepare your final year project report is, remember you submit your report to the university, right? So your report is submitted to the university lecturer, your professors, doctors. So they are experts in their fields. And sometimes you prepare your report as a textbook. So now you explain this is waterfall approach, this is agile approach. Oh, yes, they know it. So you think that you are preparing a textbook for A-level students, how to develop software? No, right? So you must know what you are doing, right? So you are doing a reporting. So they are interested what you did and maybe why. Not you teach them what is agile, what is, right? Blah, blah, blah. So that means you have no common sense. So know your audience, know your purpose, and prepare your whatever the technical document according to the purpose. Right? Are you preparing a textbook? Are you advising them? Or you just report, this is how I did, this is what I learned, this is the final results. These are the further improvements I am planning. So that should be your mindset, right? When you prepare your project report. Because it is not a research paper. So know your audience. Choose the right words. It depends on your audience. Avoid any traps, pitfalls, right? You misunderstandings and so on. Sometimes you just keep trying to increase the words, right? Increase the length of the words, right? You think that the good English is long sentences. No. Or maybe you just try to add more and more content until you get 10 pages, 30 pages, 10,500 words. No, that is not the purpose. Those are just references for you, guide. So think about the 5 C's. Right. Anyway, later part, we did look at what are the 5 C's. Right. Clarity, conciseness, completeness, consistency, correctness, and give your preferences in a proper way. Otherwise, you will get into the bad habit of plagiarism. Okay. Right. So let's little bit look at the structure. You need to have good structure in your document. Of course, sometimes they provide you the structure. This is the expected sections, subsections. Most of the time, they will just say what are the expected sections. But then you need to think about, okay, if it is, you are planning to have about 50 pages, how many pages for the topic one, how many pages for the second section, roughly. Otherwise, at the end, you ended up in 100 page or you ended up in 20 page. So there are two sub-concepts related to that. That is internal balance structure versus external balance structure. Okay, external balance structure. So what is that? So the external balance structure means you have roughly same number of pages or content for each section. Okay. So for example, if your section 1 has about 10 pages, your section 2 is also about 10 pages. Not strictly, right? Not first section 10 pages and next section 1 page. So try to balance it. Try to balance it. There can be very exceptional situations, but in general, if first section is about 10 pages, maybe the next section is also about at least 8 to 12 pages. That means you have the external balance. Okay. And if your first section has 5 subsections, then your second section also somewhere around 3 to 6 subsections. Then internal balance structure is, external balance structure means how do you structure your subsections, right? If your first section has about 5 subsections, second section must also need to have about that number of subsections. So that is external. Internal means relative size. Sorry, I completely mess up the two concepts. So if your first section has about 10 pages, your second section must also have about 10 pages. Okay. So that is called internal balance. How many subsections, how many pages, or how much of content you have in a particular section. And subsections also try to break it into the same size. Your subsection, if you have 5 subsections and if you have 10 pages, then maybe ideally each subsection must have 2 pages. Not one subsection take 5 pages and all the other 4 subsection take the next 5 pages. Okay. External balance and internal balance. Or you can do both. Actually, ideally you must do both. It's internally balanced plus externally balanced. And the result is this kind of a pyramid shape. Okay. So this is your section, subsection, next subsection, and next subsection. Okay. So this is your total. And make sure you know your audience, right? Know your audience, know your purpose. Okay. Because if someone is interested in details, you need to write details. If someone is not interested in details, no point you write details. For example, in your final year project, the people who review your final year project, they don't want the details most of the time. They want to look at the big picture. Maybe in some areas, a little bit more details about how do you test it. Maybe about little bit more details about your architecture. How do you decide that? So likewise, you must understand, okay, what kind of things these guys will be more interested. Have I presented those things? What kind of things that maybe you are interested, but maybe they are not interested. So you don't write things that you like in your reports. You write things that your audience are going to expect. Okay? That is very important because at the end of the day, you write something not for you, right? You write something for someone else. So you must satisfy their needs, not your needs. You don't write something and you read it, right? Sometimes what happens is you do things that you like. සමහර උයන්නේ තමන් ආස කෑම උයලිවල තව කෙනෙක්ට කන්න දෙන්න. තමන් ආස කෑම උයාගෙන ඔයා කන්න. වෙන කෙනෙක්ට නම් ඔයා උයන්නේ. සමහරට ඔයා කන්නේ ඒවා වෙන්න පුළුවන්. හැබැයි එයා ගැන හිතන්නවා. එයා ගැන හිතන්නවා. විශේෂයෙන්ම ඔයා රිවිව් කරනවා නම් ඔයාට මාක්ස් දෙනවා නම් නේද? ඉවැලුවේට් කරනවා නම් අනිවාර්යෙන්ම ඔයා හිතන්න ඕනේ එයා ගැන. ඔයා ගැන නෙමෙයි. මොකද එයානේ අන්තිමට ඔයා ඉවැලුවේට් කරන්නේ. ඔයාට කැමති දේවල් කරන්න ඔයාගේ ලෙෂර් ටයිම් එක. ඔයා කැමති සින්දු කියන්නේ. So know your audience. Are they experts? Are they more technical level, executive level, non-specialist? So, because if they are not very expert level people, so maybe you need to explain a little bit more details. Okay. But if they are experts, why do you want to explain so many things? Because they already know it. So then someone will ask, if they are experts, why do they read your one? Maybe for different purpose. They just interested in your progress. Maybe these guys are not technical people. These are more business. So business people are more interested about the business aspects. So no point giving them more technical details. And also for technical people, you don't need to give a lot of business details. So know your audience, their levels of expertise, their domain, business or technical or marketing. For example, if you are giving it to a high level person like ex CEO, managing director, definitely they don't like lengthy things. They just want to see the big picture, high level things, the results. But if you are giving it to your immediate manager or something, maybe they expect more details. If your audience is majority of the audience is not specialists, don't use too many technical things because they will not understand it. At the same time, if they are already technicals, don't try to explain obvious things to them. So, right? And at the end of the day, these are technical documents, business documents. Make sure it's precise, concise, catchy, accurate, relevant things. අදාළ නැති දේවල් ලියලා වැඩක් නැහැ. සමහර ෆයිනල් ඉයර් ස්ටුඩන්ට්ලාගේ රිපෝට් කියවද්දිම තේරෙනවා මේ නිකන් ලියන්න ඕනවට ලියලා කියලා. ඒ කියන්නේ රිපෝට් එක ගත්තට පස්සේ ඒ රිපෝට් එක කියවන්න හිතෙන්න ඕන අනිත් එක්කෙනා. කියවන්න හිතෙන්නේ නැත්නම් එහෙම ඒක එයාගේ ප්‍රොබ්ලම් එකක් නෙමෙයි ඔයාගේ ප්‍රොබ්ලම් එකක්. ඔයා ඒක නේද? ඔයා කෑමක් හදලා දුන්න මනුස්සයට කන්න හිතෙන්නේ නැත්නම් ඒක ඔයාගේ ප්‍රොබ්ලම් එකක් නේද? කෑම හරියට හදලා නැහැ. So therefore just think about that. ඔයා කම්මැලිකමේ බයිලා ලියනකොට අර මනුස්සයා කියවන මනුස්සයටත් ඉතින් ඒතකොට ඒ ප්‍රශ්නේ වෙනවා. තමන් නිකන් ලියන්න ඕනවට මොන හරි ලියනවා. ඒ පාර අර මනුස්සයා ඊට වැඩි කරුණයක් ගවන්න මේ මනුස්සයාට මලක් පයින්නවත් එක්ක මේ මොන මගුලද මූමේ ලියලා තියෙන වැල් වටාරන් ටිකක් නිකන් කියලා. ඒක අනිත් මනුස්සයාට ටක් ගාලා අහුවෙනවා. පටස් ගාලා අහුවෙනවා. හරි. මේ ඔයා ලියපුවා නෙමෙයි ඔයා ජෙනුයින්ලි ලියපුවා නෙමෙයි ඔයා නිකන් මේ හැලී ලියලා කියලා. So make it concise. කෙටියෙන් ලියන්න. පිටුපුරවන එක ආගේ වැඩේ නෙමෙයි. ඔයාට ලියන්න කොච්චර කම්මැලි නම් කියවන මනුස්සයාට 10 පාරක් කම්මැලි වෙන්න එපා. කම්මැලි වෙනවනේ. මොකද ඔයා ඔහේ ලියපුවානේ නේ. Make it simple, short, clear, relevant. Okay. Be very precise. ටක්කෙටම කියන්න ඕන කියන කතාව. වටේ බෑ. ජෙනරල් විදිහට ඔයා කරපු වැඩේ මොකක්ද? සමහරවිට ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එක රිපෝට් එක කියවද්දී අන්තිමට අපි දන්නේ මේක පාවිච්චි කරේ ඇජයිල්ද මොකක්ද කියලා. එයා ලියලා තින්නවද? software development කරන විදි මේවා ආය ඇජයිල් කියලා විදියක් ඇද? රප් කියලා විදියක් ඇද? ඔයා මොනවද කරේ කියලා ඒක දන්නේ නැහැ. ඒක සමහරට ඔයා ලියලාද නැහැ. මොකද ඔයා කරලා තියෙන රිපෝට් එක ලියන එක නෙමෙයි බද ටෙක්ස්ට් බුක් එකක් හදන එක. ඒගොල්ලන්ට ඕන ඔයා කරපු විදිය මොකද? ඇයි ඔයා ඒ විදියට කරේ? ඔයාට වෙච්ච ප්‍රශ්න මොනවද? ඔයාට වෙච්ච වාසි මොනවද ඒ විදියට කරපු එක? So that is what they are interested because you are giving a report. And try to put things as much as possible positive form. Positive form. මතකද මම සමහර කෝඩ් කරද්දී උනත් වැලිඩේෂන් එකක් කරලා වැලිඩේෂන් එක ෆේල් කරන කෑල්ල යටට ගන්න. පොසිටිව් සිනාරියෝ එක උඩට ලියන. ඒක කරන්න බැරි නම් කරන එරර් හැන්ඩලින් ටික දාන්න යට. Because we need to do the positive thing first. The negative thing next. When you write a sentence also, sometimes you can just convert a negative sentence into a bit of a positive sentence. And so that rather than saying do not include, you can say exclude. මේ වචනේ අරකම තමයි නමුත් මේ not කෑල්ල නැහැ. Exclude. Rather than do not permit, forbid. Because your report is your personality, right? So what we expect is positive people. So therefore try to reduce the use of words like negative things. This is also negative, yes, but you make it little bit right? Less aggressive, right? Exclude. That can be part of your character. And also make sure you write it in a very straightforward manner, because this is not literature, right? Rather than writing these phrases, just use the exact word. In technical writing, right? Use these things in your literature, chat with your friends, and not in your technical and business writing. So be very precise. And also, these are tested in your exam also. And don't try to give human-like projections to systems and so on. So that is bad. That is not professional, right? So don't say the system failed miserably. So this is maybe a person failed miserably, right? Because system is not a person, right? So don't say internet is evil. So how can evil when සත්තුනේ මිනිස්සුනේ හොල්මන්නේ. Internet කියන්නේ මනුස්සයෙක් නෙමෙයි, it's a technology. It's a system. Okay. So don't use that kind of things. Don't try to give them sort of a person, right? View of a person to technology systems. So just you are a professional. For you, it's a system. It's a process. It's a procedure. Okay. And use proper words. Okay. And you must know these words also, right? Right? මේ වචන exam එකේ question වල තියෙනවා ඒකට. Anthropometric writing. මිනිස්සු නොවන දේවල් වලට මනුස්ස ලක්ෂණ දෙන්න හදනවා. So මේ වචනත් සමහරට exam එකේ අහනවා, එච්චර වැදගත් නැති වුණත් අහනවා. හරි? Malapropism. That is, there are some words sound similar, but they are different words. So maybe you can misspell these kind of things, mispronounce, especially mispronounce, like destiny versus density. Especially these can happen when you talk, because it looks the same pronunciation. Sometimes they pronounce the same or similar, but they have different meanings. So that is called heterographs. Complement with I and complement with E. Higher and higher. Whole and whole. Silent W. So these are more important when you talk, speak, and sometimes when you write also. So then next thing is very important, opinion versus fact. Actually, we have discussed that about that in from semester 1 itself, right? So in your technical writing, business writing, be very careful. As much as possible, you need to present your facts, your findings. You can provide the opinions in special topics like discussions, but don't take your opinions to other sections. And if it is opinion, clearly mention that. What happens is some students, they present their opinions like a fact. So then the reader will think that, okay, this guy is trying to fool us or influence us. So if it is your opinion, just accept that it is your opinion, right? So don't try to make your opinions as present as fact. So that is a very bad habit. At the same time, try to minimize writing opinions in the technical business kind of things. Okay. Sometimes you can suggest, give advice, but then you can say, in my opinion. Okay. And also, when you're using acronyms, domain specific terms, or technical jargons, be prepared, be careful. One thing is don't overuse because your audience may not familiar with these words, especially if they are non-technical, right? So therefore, don't overuse them. And if you use, maybe you can refer those. These are the acronyms I use in this report. Like something like the first letters we use, right? Like OOP. Like you all know that what is OOP is, right? Object-oriented programming. But when you formally present it in a report, you better mention at least in the very first time OOP, object-oriented programming, or you have separate section list of acronyms. And don't use these words like very too often. Sometimes you just add those words just to make it lengthy, right? Because it make less professional when you use those things too much. Or maybe you find a proper word instead of keep using very. Right? Rather than very clear, you can say transparent. Very often, you can say frequently. Very weak, you can say feeble. Right? Because this is little bit too casual, right? Too casual. So these are the 5 C's. So this is very important for your exam. What are the 5 C's in technical writing? Correct. Make sure you present only correct facts, information. Clarity, you specify it in a very clear manner. Complete. Don't mention things in half part of it. Just mention everything if it is related. Consistent. Have a very consistent style, structure. A changeable means that means pretty much it can be easily modified and so on. But the first four is the most important thing. Correct? Clear? Complete. Complete doesn't mean that you write too many things, right? But when you present some idea or fact, present it in full. Otherwise, the reader may not, because maybe you know it, right? Because that is another pitfall, right? You are writing this because you know it, but that is not the case for the reader. Okay, so don't assume that reader also know it. Consistency. Okay. Changeability means like you can easily revert to a previous version of your document. You can undo things. So that is very important that is one of the advantage of using uh, electronic documents. And also content management systems like version controlling systems. And even things like can I easily translate? Can I easily export it to a different format? And make sure you give references. Otherwise, you will be doing plagiarism. And when you give references, you must follow 100% exact formats. So a lot of final year students, when they prepare their final project report, their referencing is they are doing the way they like. Definitely, the report is rejected by UCSC. So there are specific referencing formats, Harvard format, and so on. So you must follow the exact format, not the format you like. These are technical documents, academic documents, part of your evaluation. Okay. And if it is a book, there's a specific format. If it is a website, you need to specify the website, the access date, URL. But if it is a book, the ISBN number, authors, edition, and you need to follow exact format. And you can't be casual about those things, okay? Then you are going to get repeat for your reports. So you need to follow the exact style sometimes, for example, final year project, they specify this is the expected style with some examples. So then you need to strictly follow that style. So these are some common styles like IEEE style, Harvard style. Those are different. So you need to refer your reference book, your project guidelines, and first identify what is the expected. Is it Harvard style or IEEE style? Then you must know what is Harvard style. How to give a reference to a book, how to give a reference to a website. So then you prepare your report according to that. And make sure you go through these process, right? So we have discussed this in semester 1 also, semester 2. Brainstorming, drafting, revising, editing, publishing. So only here you worry about grammar and spelling. Because that is another big issue, right? When you start writing, you rather than you concentrate on the contents, you think too much about your spelling mistakes, grammar mistakes. No, don't do that at the beginning. Do that at the end. මොකද ඔයා ලියන සමහර sentence අයින් කරලා මොනවා හරි කරලා මේ හරි දෙන්න. නැත්නම් අපරාධයක් perfect grammar වලින් ලියපු අන්තිමට ඒ sentence පිටින් අයින් කළා පස්සේ. අනිත් දෙකක් හිතන්න ගියාම අන්තිමට එකක්වත් වෙන්නේ නැහැ. ඔයාගේ ඔළුවට පිස්සු හැදෙනවා. මොකද ඔයා grammar ගැනත් හිතනවා, spelling ගැනත් හිතනවා. ඔයාගේ වැඩේ ගැනත් නෑ. ඔයා concentrate කරනවා ඔයාගේ වැඩේ. ඒකෙන් කියන්නේ grammar spelling ඕනේ නැහැ කියලා. හැබැයි ඒක අන්තිමට කරන්න. ඒක අන්තිමට කරන්න. නැත්තම් ওই දෙකම mix වෙලා අන්තිමට එකක්වත් වෙන්නේ නැහැ. That is very very important. So ඔයාගේ natural writing එක එන්නේ නැහැ. Natural writing එක එන්නේ නැහැ. So these are the stages, right? Brainstorming, where you think about it, do a bit of research, you discuss with others about that. So then drafting, you start structuring your document and start your initial writing. So we remember, don't spend much time on grammar yet. Perfect කරන්න ගිහින්. Okay. Revising, right? You revive your content as a third party person, or you can revise by yourself, or you can give it to someone else also, revising. Or you can even now give it to the chat GPT and so on and ask you to give some suggestions. Then do your further editing. This is where you are more serious about grammar, spelling, and so on. Okay. Now pretty much your content is written. Your objectives are fulfilled. And of course, publishing. Final touch-ups, right? Finally, double check your referencing styles, TOC, formatting, whether you have used the correct fonts, correct margins, and publish it. If you are supposed to print it, how to do the binding, මොන binding එක දාන්නේ, මොකද්ද පිට cover එක දාන්නේ, ඒව ගැන කරනවා. Color printouts එකක් දෝන, black and white. So මේව කරන්න කියන්නේ basic, because at the end of the day we need a professionals. නැත්තම් මේක මේ වාගේ report එක ඊට සමහර කවුරු බලන්නෙත් නැහැ. ටික දවසක් ගියාම කුණු කෝඩේට දානවා. නමුත් මෙතනින් ආව හදලා ගන්න ඕන. නමුත් අපි ඊට පස්සේ ඩිවෙලොප් කරන සිස්ටම් එහෙම වෙන්නේ නැහැ. ඔය මේන්ටේන් කරන සිස්ටම් එහෙම නෙමෙයි නේ ඇත්ත කතන්දර. ඔයාගේ ප්‍රොජෙක්ට් එක ෆේක් වෙන්න පුළුවන් ටික. ඒකත් ඇත්තට ප්‍රොජෙක්ට් එකක් කරනවා නම් අමාරුයි. Right. We'll stop at this point, right? Thank you.